Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Welcome everybody to the third day of the conference. I have the pleasure and at the same time unfortunate job to introduce Mr. Becker, a guy who probably doesn't need an introduction at the Lightning Network conference because he's kind of co-invented it, I would say. So I'm very excited to hear what you're going to tell us about running Lightning at scale. I assume it's about Greenlight, so I guess this will be very interesting for everybody. The stage is for you.
I hope so too. Thank you very much for that introduction. Can we turn the audio down a bit? Okay, thanks. I can't listen myself to speak. So. Okay, my name is Christian. I'm a principal engineer at Blockstream, and I have been working on a system called Greenlight for the last couple of years. Greenlight, for me, has always been an attempt to get the trade-off for a running Lightning node more in favor of beginners and new users. I think of Greenlight as essentially the training wheels for you to learn how to ride Lightning, and eventually you'll graduate and you can take the training wheels off, and we just want to see how far can we push it, right? Because we noticed that essentially, running a Lightning node takes a lot of expertise. It's not easy, and trust me, it's not easy for us either. I can only imagine how daunting it must be for a new user joining, essentially being confronted with this huge amount of knowledge you have to acquire before even being able to handle Bitcoin the correct way, right? So the goal here was essentially, we wanted to have an offering that would allow new users that have no experience whatsoever with Lightning and Bitcoin to have a first experience of what this system can do for them and how they can profit from them. Show them the utility of how Lightning works and how good it is for you to take on responsibility for your own funds before presenting you with the challenges of actually operating a node yourself. Because many people are lost along on the road to self-custody and non-custodial setups. So people will end up on the custodial range of offerings. And we thought there must be a better trade-off in the spectrum, and Greenlight is exactly this attempt. So our goals here are relatively simple. We'd like to make it attainable for anybody to run to own a Lightning node. We want to take on as much responsibility of operating the Lightning node ourselves, so that you, as the end user, are free to see the positive sides, and we hide the negative sides from you, essentially. To achieve that, we are actually running a core Lightning node for every single user that has signed up on our system. Core Lightning, of course, being the implementation that we spent years building before that, and it's what we have experience with. So one user, one node to isolate each tenant from each other. we want to shield these users from the complexity. And like I said, we want to be the training wheels. We want to be your first onboarding experience, motivating you to dig deeper and take on more responsibility further down the line. And for that, we are also offering for you to essentially take the node that we ran for you on Greenlight and offboard it into your own infrastructure, all without interrupting any applications you might have bound to this Lightning node. So the problem is, how do we do that? A couple of months ago, we surpassed the 250,000 nodes, so 250,000 Lightning nodes on essentially shoestring budget, right? We are able to support all of these users by applying a number of tricks, by realizing certain possibilities that we saw while operating nodes and taking advantage of them. And the most important one is probably the illusion of the always on, right? We essentially don't run 250,000 nodes 24/7. That would be wasteful. It wouldn't even be possible in many cases, right? One of the fundamental things that Greenlight has is we segregate away all of the private keys from our online services. So our operators, our servers never see your private keys. And so we need the end user to be present when there is something to be updated, some change in the funds that the node is controlling. What we do is we actually ask the user to sign off on it after having verified that it actually is in line with their intents. So oftentimes users aren't there, right? Their phones are off. They might be out of battery. They might be flying over the ocean, or in my case, hopefully, I'm sailing outside of the reach of mobile phone coverage. So sometimes you simply cannot sign off on changes, and we make use of that finding by essentially saying, why should we even run the node when we can't sign off, right? These are end user nodes. They're not there for routing. They are essentially the first bike with training wheels that you're running. So what we see is that the typical user checks their wallet app 3 to 4 times a day. So what that means is that we could essentially just intercept when the user wants to talk to their node, spin it up just in time, let them have a nice discussion, and when they're done, we just spin it down again. Relinquishing those resources to the pool that we could run other nodes on. So yeah, we essentially just do that. We realized we couldn't make any updates, so we shut the node down, and by optimizing how quickly we can spin it up again, we literally have these nodes back online and running. They take about a second to start up. They take about 2 seconds to reconnect to their peers, and they take about 3 seconds to sync down all of the gossip, such that after a total of 3 seconds, which in many cases is quicker than a mobile phone app will load, if you've ever seen those lengthy loading screens, we're quicker than that. So the node is essentially there when you need it, right? And this is the illusion of always on, as I like to say, right? You think your node is always there, and we just make sure it's there when you need it. Well, that's the principal idea behind how we scale out. Let's see a couple of the building blocks for this. I will go into a bit more detail about how we achieve the scale that we do, what kind of tricks are we using, and some operational details that I just find funny. You'll have to bear with me for that because I also like operational stuff. Cool. Like I said, the fundamental building block for all of this system is Core Lightning. Core Lightning is our implementation that we've started, that Rusty has started in 2015. I joined a year later, and we've been chugging along at it for a while. The team has grown considerably by now. Many of them are here in the audience, so go talk to them if you want to know more details about how Core Lightning started, how it works. But for us, the important part is that right from the get-go, we decided to split the node across different domains. The domains being, of course, what the functionality is. Everything gets its own little component. So we can see that, for example, we have this red box, which is the main daemon. That is essentially the coordinator of everything that is happening in Core Lightning. And it is the thing that provides persistence, that starts up and stops subdaemons, and so on. And on the right-hand side, we have what we call subdaemons. And these subdaemons each have a very specific job. So for example, the topmost one, ConnectD, is the thing that handles all of the connections to the peer-to-peer network. So all the messages that come and go from our peers will go through ConnectD, will then be scattered around the various subdaemons, and we then we will also send messages back through ConnectD. We have GossipD. GossipD is what handles our view of the Lightning Network, and it is what all of our routing decisions are based on whenever we want to perform a payment. And most importantly, probably for this talk, is the aspirationally named HSMD. Don't be fooled, it's not actually running on an HSM, it's aspirational. But what it does is it essentially encompasses all the cryptographic operations. It is the only component that ever touches your keys. And we will see later how we make use of that to actually move the ownership around in this system. And of course, we have the blue boxes below, which are plugins. So plugins are arbitrary scripts or programs that talk with the main daemon over standard in and standard out. So even brainfuck can do that. So I'm still waiting to see the first whitespace and brainfuck plugins, but they're definitely possible. Would be a challenge though to get them working, I guess. And why did we split out these individual functionalities? Well, because we're big subscribers to the Unix philosophy. So we do one thing at a time and we do it well, right? That is a core principle of both Unix and Linux. And while that may seem simple, by combining and recombining and swapping out individual parts, we can build systems that are arbitrarily complex while still having very, very simple base components that are easy to reason about. And it's a recombination that gives us a lot of power. So, of course, if we just saw the Core Lightning architecture, what could come next? The green light architecture. So what we do is we take Core Lightning and we move pieces left and right into different domains of control, as we shall see later. But before we get there, let me show you how the always-on illusion actually works. So what we see here are essentially some shared components, the scheduler, the router, tower, and the proxy. And these boxes here are essentially slots, or what we call nodelets. If you've ever looked into Kubernetes, kubelet, nodelet, they are essentially chunks of resources that we can allocate computation and functions to. So what happens when a user opens the app, for example? The user, which I represent with this yellow box on the left-hand side, has an application A and a signer A. A being essentially the name of the user. I usually draw them separate, but they can absolutely run in the same application, and most applications actually do run them at the same time. So the user opens the app. The app is configured to talk to something like gl1abc.nodes.gl.blockstream.com. And that is a unique string, that's a unique URL for every single node. So they will try to talk to their node, expecting it to be online. The request comes into the proxy, and the proxy is smart. It reads the TLS header. The TLS header will contain some metadata called the SNI, the server name indication, telling us which node they're actually talking to, right? We have encoded the node ID inside of the URL. It extracts the node ID. It will talk to the scheduler. The scheduler says, yeah, look, it's running there, or nah, it's currently not running. Okay, then start it, please. So eventually, the scheduler will schedule this nodelet with the node, making it essentially start up the node, and we wait for it to have started up. And once it is ready to connect, which again takes about a second, the proxy can forward the connection to this node. The thing that is important to underline here is that at no point did the proxy see any of the content of the discussion itself. It is handling an encrypted stream, it is not decrypting it. The node is the only one that has the private keys for the TLS certificate that we use to encrypt the traffic, so only the node itself can decrypt it. And I'll tell you why that is important a bit later. But we've essentially just started the yellow node on that nodelet, and the signer can connect to this node proxy as well. The signer is receiving essentially signature requests from the node itself for operations that it performs, such as, oh, I need to open a TCP connection, a peer-to-peer connection to a peer. That peer-to-peer connection includes a handshake with the node ID. So to open a connection, for example, we need to talk with the signer. The signer gets the request, verifies it locally, and sends back whatever has been asked for. Usually it's a signature. And then we can connect to the rest of the Lightning network, which at which point we can then just resume normal operation. All of this took less than a second usually. It takes less than a second, well, 2 seconds for the connection reestablishment. And again, your app usually takes longer to load on your phone than this. So the illusion is quite nice that you just talk to a URL and we will make sure that it's running where it's at. So why are we handing through encrypted streams here and not, I mean, this node is still running on our infrastructure. We will eventually decrypt the stream, or will we? I told you before, these are training wheels, right? We hope you will eventually have gotten enough utility so that you're encouraged to read up on how things work, how you could operate, and how you could take ownership of your own node. So what we offer to you is, once you feel you're ready, you can export your node, which is essentially just a Postgres database dump. We will mark it as export in our database. We will not start it anymore. You take the snapshot. You hydrate essentially a Raspberry Pi or whatever hosting infrastructure you choose to run at home or run on your own VPS. And at that point, we no longer have the decryption keys for this. So what happens is that your node would essentially run somewhere here outside of the Blockstream infrastructure. The connection comes in, the proxy sees, oh, I'm no longer running this, but I have knowledge of where it is running. It would connect outside here. And we would still provide you access to your node, but we won't be seeing anything that goes through it. We will see that bytes are being shuffled around, but we cannot interpret those, essentially. So what we want to offer you is to essentially take the node, take ownership. We still want you to provide you with additional services that make it more accessible. If you've ever tried to set up NAT or configure a firewall, or even run over Tor, you will probably know the pain. And it's even more painful if it's your family and friends asking you how to do it, right? That's the pain of being the support for friends and family, I guess. And so by doing this, we try to take away as much pain from operators as possible. But you don't have to use it, essentially. Okay, how? So if you've seen Fabrice's talk yesterday, there was a lot of discussion about why sort of segregating the signer from the node itself is not really doable for them, because essentially taking the signer off without also implementing a lot of the logic of Lightning itself would just mean you're blind signing everything, right? I have this request, I throw it over the wall, the other side just goes like, sign, throw it back over the wall. You've not gained much with that. So what we wanted to do is we wanted to essentially go the other way. We don't have one node that needs huge performance. We don't run routing nodes like this. What we do is we run small nodes, but many, many, many of them. So for us, we wanted to, and of course, we don't own the funds on those nodes, right? I don't want absolutely any way that I can fuck this up. I want the user to be not just self-custodial, but I want them to be the exclusive custodian of their keys, right? You're still trusting a custodian even if they give you a copy of the keys. So I don't ever want to have those keys in the first place. So for us, running everything in a secure enclave like Async does was not an option, simply because it would mean that those keys, even if in a secure enclave, are still on infrastructure we operate. And we just don't want that. So what we have is we have essentially these three domains of control. Who owns and operates what part of the ecosystem. And we can see, for example, that in the Blockstream control domain, we have all of the node itself. The network is a bit special. There is no one that actually has control over it, but it's sort of the extreme case there. And what we do is we take this component, what used to be the signer, we replace it with a proxy. Instead of now holding the keys, it receives all requests, it buffers them locally, and when a signer attaches to the plugin that provides access to the rest of the system, these requests will actually be fed down to the signer. And the signer will see the request, we'll see what the current state of the system is. We'll verify the state against the request against that state, and if it believes, oh yeah, this is a legitimate signature request, it will sign off. We were really lucky that right at the time we were looking for a signer, we ran across the VLS team, who have built or have re-implemented a lot of the Lightning policies for us already. And we got a bit lucky there, and we just decided to adopt it. And it's been working wonderfully ever since. We've built a bit of extra infrastructure on top of it. So now you don't just have one signer, you could run as many signers as you'd like. As well as you could have any number of applications. So truly your node becomes the integration point of all of your financial applications. Whether it's your kid having access to your Lightning node, your online shop paying out of or into the same Lightning node, your tipping functionality all running off the same Lightning node. And by replicating the signer, what our hope is that even though individual devices might go down, hopefully at least one of the signers will be present to wake up the node when we need it. If you're wondering why the application and the signer are split, that's because having a signer co-located with your application is essentially root access. And we want to have a way to constrain access of individual applications to your node, so that you could, for example, give out access to your accountant and get only read-only access to whatever is happening on the node, whereas maybe the point of sale needs access to create invoices and stuff like that. So you can even inside of your application, you can split responsibilities and make sure that everybody just has access to whatever they need to fulfill their job. And of course, we don't just do that once, we do that hundreds of times. So at any point in time, we have anywhere between 25 and 2,000 nodes running concurrently. That's also quite a bit of infrastructure required there. So we scale automatically the number of slots that we can support at any point in time. But that is essentially the concept. So what we ended up here is doing, we took this box, which is a signer, and we moved it into a different domain. So that is splitting the node across sort of the responsibility lines that we have inside of the node. But we can also do the other direction, right? There are a couple of central services that benefit from being centralized. So for example, we have a watchtower implementation that all nodes need talk to. There is no point in running a watchtower for every single node. We just run one. We also have a router which collects and aggregates our network view over time and feeds that to the node. As we shall see, that is of paramount importance, because if your node is offline for prolonged periods of time, there is quite a bit of updates in the Lightning Network that you might have missed. So what we do is essentially start up the node and we send you, first of all, a snapshot of the current gossip. And from there on, we send you incremental updates as they come in. What that also allows us is to tweak the routing. So for example, if we notice that some node is misbehaving, we can just sort of blocklist it. If there is a route we notice is working really well for us now, well, prioritize that. And by just having the single point of contact with the router, we can tweak and instrument every single node in our fleet. So sometimes we move pieces from one domain into the other, and sometimes we aggregate into single entities for efficiency reasons. I already mentioned this, but the segregated signer is paramount in all of this construction, right? It is what is giving us the non-custodiality of the service. We never have the ability to move any of your funds, and that's good, because I probably wouldn't sleep if I had this ability. Never touch somebody else's money. So how does this work? What we essentially have is the application initiates some operation. So let's say it wants to pay an invoice. So the command is essentially pay, and the payload is the invoice. And what we have here is that every single client application has its own identity, which is known to the signer. There's a relatively complex handshake that allows us to have the signer add a new device, add a new client that is authorized to execute certain things on a node. So the client essentially just takes the command and signs it. The node receives the command, oh, I should pay this invoice. So let me prepare all the steps. Let me compute what I need to change. Where do I need to add an HTLC? Where do I need to compute a route? Maybe involving some centralized services. But what the ultimate outcome is that we need to perform some change in our funds. So since there are funds involved, we obviously need to involve the signer. So what we do is, ultimately this results in a signature request plus the state, which is kept on the node itself, but signed. And the signer takes the state, hydrates itself, and there is one more thing, it's a context here. So those are pending RPC commands. It's this command, essentially. It's a list of these. So what the signer can do is what we call end-to-end verification. Oh, I see this change to my funds. Is there something that authorizes this change, right? Is there a command that could be the cause for this change happening? And indeed, I'm being asked to add an HTLC. Do I have a command with an invoice pending with that payment hash? And so even if an attacker would gain access to the hosting infrastructure of the node itself, they could try and issue pay commands all day long. The signer would say, I don't know where that comes from. I'm refusing the signature. So what we have here is a way that we have the app communicate with the signer through the node in an authenticated way. Plus, there is a bit of authorization as well, but I'll skip that part. The slide is already busy enough, I guess. So after having verified all of that information, what you do is you send back the response and the new updated state, because the signature request might actually have affected some change in the state itself. We will save that state, and the next time any signer comes along, we can just feed it the whole package of state plus request, and it will be able to pick up where any previous signer left off. So that's how we also operate the multi-signer setup. So I just mentioned that I want to sleep well at night, not knowing that stuff is secure, right? So how do we actually implement the secure tenancy, multi-tenancy? All over the place, we use mutual TLS authentication. And this is a trick I'm pretty proud of, but it might seem too simple. What we have is we built a hierarchy of TLS certificates. And if you wanted to talk to a central service, that service would ask you to have a child certificate of the root. So any node, any client, any signer can access the central services. But the moment you want to talk to, for example, user A's node, you need to have a certificate that hangs off of this subtree. And what we have with this is essentially perfect segregation between users. Because if user A user A's device wants to talk to user B, there's a mismatch now. They cannot complete authentication. So simply by the structure of the TLS certificates, we've ensured that everybody can just talk to their own node, never across. There's also a second aspect to multi-tenancy here, and that is we give every single user gets their own database. So these are running Postgres databases, and essentially what we do is we have a big Postgres cluster. It's about 4 terabytes in size, and it has literally 250,000 schemas in it. And if you want to export your node, we will just give you your schema, encrypt it with one of the TLS certificates that is requesting the snapshot. And by doing that, there is no intermingling of user data at all. And we can safely remove or move these databases around whenever we need. And since I'm getting close on time, let me just add one thing that really surprised me, and that probably a bit of napkin math would have prevented me from the surprise, but oh well. We have 250,000 nodes. We have 144 blocks a day. Let's say these are on average maybe 2 megabytes in size. That means that on a daily basis, we're shuffling around 72 terabytes of data just to keep the nodes up to date. Because what we do is we want to keep your node operational whenever you need it. So nodes are not operational when they're lagging too much behind the blockchain. So we have a whole separate cluster that does nothing else than to wake up nodes that are lagging behind the blockchain. where a signer may or may not be online, but we can process blocks without the signer being present. If there is if it encounters some operation that requires signature, it will shut down the signer and will try to notify the signer to please come by. We need you. We need you to sign off something. So that I found really impressive. Anybody want to guess how many Bitcoin D nodes that makes? No guesses? Somebody mentioned one. You're almost right. We have two regions. It's US and EU. So all of that is duplicated, of course. So we pump 72 terabytes of data out of one Bitcoin D per region, so two Bitcoin Ds in total, using RPC. I see your face, and I would agree. Bitcoin D by default has 4 RPC threads. It has a back queue of 128. We have thousands of requests a second, so it's really very likely for us to essentially exceed those limits, and that would be bad because we would essentially get and the core Lightning nodes would essentially exit loudly, as we like to call it, or crash. After about 60 seconds of unavailability. So we would have nodes crashing left and right. Luckily enough, Bitcoin is almost content addressable. So it's really easy to cache. So for example, the get block hash, that's an API call we cannot cache that well, right? We might have a fork, a previous negative result that there isn't a block at this height. There might now be a block at this height, so that one we should not cache for long. But get block, well, get block we call with the block hash. That is exactly what content addressable means, right? We look up a piece of information by some checksum of its content. So what we end up doing is get block hash gets cached about 10 seconds. Get block gets cached for 2 weeks. Because why not? It doesn't change, right? So by fine-tuning how long we cache individual parts, we can make this a very, very performant system. So what we ended up doing essentially is we have 2 levels, 2 layers of a cascade of caches. Each Bitcoin D is fronted by a cache, and each host running core Lightning nodes also has a local cache. So everybody just talks with their local on-disk cache. And if there is a cache miss, well, we go up 1 level. And eventually we end up on Bitcoin D. Bitcoin D, for the most part, is just idle. It doesn't do much. All of this traffic that I was so impressed by is actually handled by a 150-line Python script. That is literally the XKCD comic of that small little wooden block holding up this huge thing. But it's working. So I found that really interesting. And with this little anecdote of how even the best laid plans can stumble over something unexpected and still make it out there with a tiny little bit of ingenuity, that is what I wanted to end with. So thank you very much. I hope it was interesting for you. And if you have any questions, please. Thank you.
Thank you, Chris. And we do have time for some questions.
Yep, I see one here.
So you mentioned that the state has to be passed to the signer. Mm-hmm. How big is that?
So we actually optimized that quite a bit. So my background is distributed computing. I like these kinds of challenges where you have a bit of data syncing around. So what we did is we took the state that the VLS signer requires. We sliced it into different chunks. So for example, each channel is its own shard. The list of invoices is its own shard, and what we do is we have a diff map or a sketch on both sides of the connection, on the node side and on the signer side. representing what I last sent the other side. So when state comes back from the signer, there will only be the shards that have changed. And the same way, I will only send down any changed shards when they're needed. We've seen all shards taken together, states that range from 100 bytes to 4 megabytes. 4 megabytes is the limit what protobuf will allow you to send down the line, by the way. So at that point, we needed to be a bit creative, but we managed. So initially, once you connect, yes, you get the whole package, but from there on, you should only do a differential sync every time. So that's very, very small. Once you've reached that moment, yeah.
How do you handle updates, for example, Bitcoin D or Core Lightning, or even the database?
Yeah, so the database doesn't change that much, to be fair, right? Postgres is a very mature piece of software. We use a managed Postgres instance. There is some downtime sometimes, so there might be users that may have a temporary blip and may not be able to access their node, but the overall system stays up. We configure the clusters in such a way that sort of the blast radius isn't huge if a database is in maintenance. The Core Lightning versions, well, what we can do is we can stage them. But there is a strict coupling between signer version and node version. So what we do is we stage the next version of Core Lightning on the server such that when a matching signer comes, we can upgrade the node. So we stage Core Lightning, we send out the updated signer. The signer will talk to the scheduler and say, hey, I went from version A to version B. Please upgrade my node. We upgrade the node by essentially saying, oh, this is now version XYZ. And the actual upgrade will happen when the node is scheduled next. So that's where we apply migrations. And the client side, we can just update normally, right? It's just an app. The server side being having to be in lockstep with the signer is the only difficulty that we have to deal with. That is maybe a bit out of the ordinary, I guess. But I have to say, VLS is doing a really, really good job at having multi-version capabilities. So a single VLS version can run against a number of Core Lightning versions. So while we don't have that yet, we plan to eventually have gradual rollouts so that even if the client is upgraded, we can selectively upgrade nodes on our end to verify that it still all works before sort of committing everybody else to the upgraded version. So we can even do A/B testing a bit, so cool stuff.
How many people do actually export their node? I mean, is there demand for like the exporting thing?
Sadly, so far, not so much, but we've had a couple dozen of nodes that have been exported. And some of them are still alive. I would say maybe 10 or 20 are still alive of them. It does still require to jump through a couple of hoops, and it certainly does require you to have a bit of operational experience. And honestly, the docs aren't quite there yet. I'm an engineer after all, right? But the tooling is all there. So we have published everything that you need to make a Core Lightning node look like Greenlight and act like Greenlight. So you can do that right today, but it's a bit adventurous at the moment, I would say. But it's definitely the goal for us to eventually give that opportunity. And we hope that maybe some of the node-in-a-box, Raspberry Blitz, or even a VPS provider might create templates for you that facilitate easier offboarding into a self-sovereign setup.
Thank you very much. Let's hear it for Christian.
Thank you.
In just a couple of moments, we'll have OpenSats grantee Nicholas Goline telling you how to implement Lightning in 2 minutes here.
Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Ladies and gentlemen, welcome back to Bitcoin main stage, the final day here in Berlin. We have Nicholas Goline, OpenSats grantee, to tell you more about implementing Lightning. Please give a very warm welcome to Nicholas.
Thank you. So today I'm going to talk about implementing Lightning from scratch, from the spec. I'm doing a clean room implementation, so before doing this, I didn't have that much experience with Lightning, so I didn't know exactly what a HLC was. And then I decided to understand how Lightning works by implementing Lightning. And I choose .NET to do this. So what about using an enterprise language for open source software, right? These are I'm going to cover. So let's start from the beginning. What is .NET? How many of you here, by show of hands, know what .NET is and how it works? Okay. So not impressive, but those numbers. So .NET is a free and open source managed computer software framework for Windows, Linux, and macOS. It was a new platform based on internet standards. So prior to this, we had C, C++, Visual Basic from Microsoft, and other languages, but none of those languages were made for the internet age. So Microsoft decided to create a new language built for the internet age. So July of 2000, they introduced the language C#, the main language of .NET, at the PDC. And then December 2001, they published the Common Language Infrastructure, and the C# was published as an open standard. Meaning there's two ECMAs for this, one for C# and one for the intermediate language. So anyone could implement a new language following the standards to work with .NET, and anyone could implement a compiler to make this intermediate language work on any architecture or operational system. So the architecture here is you have the C# code, VBNet code, and J# code. They did this for people migrating from Java to .NET. So we have J#. We don't have this anymore, but it was there on the beginning. Then you have each compiler, and the compiler would compile this to this common language infrastructure. So it would compile to a pre-machine code level language. And then this set here, we have the common language runtime, which then compiles the code to machine code. So this is the main difference from Java. Java has a virtual machine, right? So when you're trying to execute code, a Java code, it puts up a virtual machine, and then your code executes inside a virtual machine. In .NET, there's no virtual machine. So you're running machine code for that architecture and operational system. So we have this CLI. It's a language neutral platform. You have CLR. There is a runtime that compiles the language ultimately to machine code. And then we have the assemblies, which is the pre-compiled stuff. Like you write code in C#, and then you have this assembly. And then this assembly has a unique name. So we get the simple text name, version number, culture, public key, whatever. And then you have this version of the executable. This will be important later. And we have class libraries, built-in API for .NET in two separate namespaces. It's Microsoft.something or system.something. We have web servers. We have JSON serializers, deserializers. We have memory, access, I/O, everything from Microsoft. So the framework is pretty complete. One of the key factors here is that NLightning has 3 external dependencies. Everything else is from the framework. So I have Microsoft on my side, and I know they will not break anything, right? Some design principles for .NET. It's interoperable, so it was firstly built for Windows. So we have this COM systems. We could talk to other infrastructure on the operational system. We have access to p-invoke, so process platform invoke. We can access OS calls from Microsoft, from .NET. And we can do reverse p-invoke. So we can write a library that can be called from a C++ or a C code or Go or Rust or whatever. We can call this as well. And the language is independent. So we have a common type system. And any language that wants to work with .NET just have to follow these data types. And it will be supported by the intermediate language, and then ultimately will be running as machine code. We have type safety, so everything is strongly typed. And up until .NET 4, it was 100% statically typed. And then after 4.0, we started adding some dynamic language. So you can have like a JSON parser. You don't really know what you're going to get. And we can do this in runtime, just get something, and you can try to access using reflection, try to access the properties inside of that class that you don't know what it is. This was very powerful for the web world, right? And portability. The first framework was Windows only, but you're going to see here that just a few months after it was released, people started working on a compiler for Unix. So right now it's fully Microsoft and it's fully open source. Security, this is important as well. As a runtime, we need to make sure your program or the program you're running is not accessing stuff that it shouldn't have access to. So it has this this layer of security where your code registers on the OS to use some interfaces or something, and it makes sure you are not trying to access stuff you don't have access to. Like if you don't ask for permission to use I/O or some folder, it will not allow you to access that. So you can run on a sandbox out of the box. One thing here, it's everything that you write and you export this DLL, it's unobfuscated. So anyone could grab a disassembler and see your source code, right? Because at the end of the day, your C# code, your VB code will be like the intermediate language. And we can recompile this to C#, disassemble this again. But we have a lot of tools for like enterprise level stuff, so you don't want your anyone seeing what you're doing on your software. You can do the obfuscation with a lot of tools, including a free one from Microsoft. Well, memory management, this is important. Everything is handled by the runtime. So if you need memory, like I need an array of bytes, and you ask this for the the runtime has some memory pre-allocated, and it gives you memory. And then you have garbage collectors. So whenever you don't have pointers to that memory, like it knows it's not being used by your program anymore, then it marks it as not being used. It can be collected, and then in a next run or several runs after this, it will just reclaim the memory and put it back to be used on other applications or your application. And this is important because we usually don't have memory issues on .NET programs because it's being handled by the runtime, right? Performance. This is something that people confuses a lot with Java because when you try to run a program in Java, it has to put up the VM and then put your software there, and then it runs, and it always is slow to run. In .NET, the first run is always slow because it's intermediate language, and it has to compile to your architecture and your operational system. So it will compile at runtime just once. And then on the next run, when you do .NET Run and your package, it will see that that signature already is compiled to that architecture, and it just runs. So from the second run on, it's pretty fast. We also have ahead-of-time compilation. So you can pre-compile for machine code for, let's say, Arch Linux on x86 64. And then you just have an executable with the .NET runtime inside of this package. And when you run it, it's running the runtime and your application, and you don't need to install .NET or the framework, the runtime, anything. You just run a software, right? So you can, it's very portable. You can just export your executable, and people will use it without needing to install anything. We have a garbage collector. We don't know when it runs, like our garbage collectors. So we don't have much control. But for very specific applications, have done this in the past, you can tell the compiler, you can pressure the garbage collector to collect more often. So whenever you're doing unsafe stuff on .NET, so I'm working with pointers and my memory, the garbage collector doesn't know about it, so you can put pressure on the garbage collector, like, yeah, I just grabbed some memory from the operational system directly. So I have this 1 megabyte, so I put 1 megabyte pressure on it, so it will run faster. And we also have, for very specific case, you can do gc.collect. And then we'll force a garbage collection. So I had to do this only once in 16 years. So, but it's there. It's good to know that you will know when the garbage collector will run. Because the garbage collector pauses the execution of your code and goes through the tree to see what it can collect, it's level 1, now it's level 2, what is level 2, now it's level 3, what can be collected, and all of that. And it takes some time. It's not slow, but it takes some time. In some applications, you have to have control over that. this is the most important part of the presentation. People still think that .NET is Microsoft, it's closed source, and it's not. So we have an apostasy here. In July 2000, introduction of C#. January 2001, so just 6 months, we have .new. So I forgot the name of the guy, the new guy. He decided to, he liked it a lot because working with Windows applications on Linux, it's always a mess. So he's seen some good stuff on what was going on with .NET, and he releases .new. So an open source implementation for Linux of the compilers, the runtime, and everything else. Then July 2001, it becomes mono. So it's this implementation, but now with funding, with more developers. It's not a single person anymore. In June 2004, mono first version, like the very stable version, was launched. The problem here is that mono is not 100% compatible, or not 100% of the API for .NET runs on Linux. So there's several calls you cannot do. There's several stuff you cannot do directly, like with memory or some kinds of lists and whatever. So in 2012, there's a legal battle between the mono guys and Microsoft, because on the patents, it was not clear if you could replicate code from the .NET repository on your own code. So they revised the patent, and just, it was like, yeah, we did this, but now it's really free and open source, and anyone can use any part of what we have on the GitHub. So Mono start copying a lot of stuff from Microsoft repositories to his own repository. And then Mono starts getting more compatible with the same software that we run on Windows, you could run on Linux and macOS. And then in 2014, Microsoft has its take on Linux. So it does the .NET Core. So they call it .NET Core because it's only the core APIs working on Linux, not the full API. And then it goes on until November 2020. By then, they stopped using the core branding for Linux because it was .NET Framework and .NET Core. The framework was for Windows and core for everything else. And then it merged, and now the .NET API is fully compatible for Windows, macOS, Unix, and all. So we have stable releases every November. Even numbers, LTS, odd numbers, non-LTS, so 3 years versus 1.5 years. And they try to minimize breaking changes. So if you wrote a code from .NET Framework 2, it would still run on newer runtimes because there's minimal breaking changes. A little about what I said. So Miguel de Icaza from GNOME, Ximian, Xamarin, he created a Mono, the open source implementation. A little about the story. So I already went through this. So about myself, so what am I doing here? I have experience working with a lot of languages in my career and in my life. I started programming at an early age. My mom was a programmer, a COBOL programmer. So she cheated me a lot when I was very young. So I always programmed like, as a hobbyist at home, doing stuff for family companies, you know, all of that. And then 16 years ago, I decided to go full developer. So I left my dad company and decided to do it by myself. I have a lot of experience in embedded systems from that early period, like 19-something. A lot of what we did was like 8-bit computers, PIC, microcontrollers. And then when I got into like a professional developer, I got into mission critical applications from the get-go. So I worked on banks, Brazilian banks, some credit card acquirers in Brazil and outside of Brazil, and transportation, like the subway system in Brazil. There's a lot of things to this day that is my code running. I worked with NFC cards, like the hardware part of it. And so always doing mission critical applications. So if I fuck up here, people don't get home on the subway. So millions of people not going home because I did something wrong in production. So I'm bringing this experience to the open source software community, right? And I see a lack of this responsibility in open source, especially in Bitcoin and Lightning. It's very sad that we have softwares that are like 12 years old, and the first line on the GitHub is run at your own risk of financial loss. I did this, but don't use it. And we have like $1 billion on Lightning channels running on software that people don't vouch for, you know? So I'm trying to change this panorama here. So I'm bringing all of this enterprise experience to open source. I've been working with Bitcoin for the past 8 years. So I got to know Bitcoin in 2009 with the paper. I didn't realize it, like how good it was. So it took me a lot of years. So in 2016 to 17, I shifted my life 100% Bitcoin. So zero balance on the bank. I don't declare like, I don't have to declare to the IRS because I have zero money. Every end of month, I have zero balance on the bank because I'm no one, right? And then I realized that I needed to bring this enterprise level software to Bitcoin. So I worked on a lot of exchanges. I did some crazy softwares I was talking about early today, like an order book for an exchange in Brazil using .NET, processing 1.6 million transactions per second. So, and I replicated this at Zebedee. I did a transaction processor there that on the first iteration we were processing 1.9 million transactions a second, end-to-end on the database, like API to database. So .NET is very powerful. So I decided to bring this to Lightning as well. I've been an OpenSats grantee since July 2024. It's been hard to get a grant because why another implementation? Why .NET? Are you insane? We already have 4 implementations. We don't need another one. So it's been very hard to get acknowledged about what I'm doing. So that's very important for me to be here, and Lisa have asked me to come and just show you guys. Who uses .NET? This is important. Everyone uses .NET on the fiat market. All the banks, you can see the Bank of America, HSBC, Wells Fargo, JP Morgan, Citigroup, AIG, Allianz, so insurance companies, MetLife, Prudential as well. Stack Overflow is built on .NET. So everyone here uses .NET every day, right? Dell, GoDaddy, Accenture, UPS, and we have a game engine. So any gamers here, you're using .NET every day on your PlayStations. It's running .NET. So it's very powerful. And we have free open source softwares using .NET as well. So BTC Pay Server, this is the biggest one, right? And a lot of people here might have contact with this. It's very powerful, and it runs flawlessly. We have some, anyone that runs your own media server at home, radar, sonar, LiDAR, everything is built in .NET as well. And we have like Nope Commerce that is huge, Umbraco CMS, everyone uses it. And it's free open source software. So why .NET? I want to make the barriers smaller for the huge companies out there, like Bank of America. If they want to use Lightning, they probably will want to run their own infrastructure. They will not leave like money on the table for other companies. Banks knows how to make money, and they want money for themselves alone. So they already have tens of thousands of C# developers on the payroll. They will not hire a Go developer. They will not hire a Rust developer. You know? So they already have C# developers. If I'm doing a C# implementation, they might run it. Right? There's a chance. And they already uses the Microsoft ecosystem. They have Azure cloud servers, SQL servers, etc. And there's free support from the community. The community is huge. So .NET platform, we have 444 people on the not the repository as well, but we have a lot of people doing this. And we have Microsoft vouching for them and financing some of the developers. We have enterprise level support from Microsoft. This is very good. If Bank of America decides to use NLightning and they found a bug, I cannot fix it, they ask Microsoft to fix our bug. And they will fix it because they're getting paid by Bank of America. So can you imagine this? Microsoft working on a Lightning implementation because they're being paid to do so. So this is good as well. It's battle tested, ease of integration with existing services, like I show you guys. Everyone uses .NET on the fiat market. It has a huge performance, like 1.9 million transactions a second, end-to-end. This is impressive. It's easily scalable. It's a multi-thread language, and it also landed something from Node.js. So it has an event looper, and it's multi-thread. So the runtime just knows if it should put this on a new thread or on the event looper, so it runs in parallel, right? It's secure, so banks are using it, and it's portable. We can run it on macOS, Linux, even Android. So the NLightning endgame, what I'm doing here, I want to have a library on par with the spec. Right now it's 75%. It's only missing both 4 and both 7, Onion and Gossip. It enables devs to create .NET apps making use of the Lightning library. We have a package called NLightning.boat11. It's a Boat 11 parser. And it's being used in production right now. Like the day I put the package out, Zebedee started using it. So it's already in production in Lightning. I want to implement a dropping Daemon replacement. So we are already working on some translation layers, so you don't have to change anything. You have LND, you point to NLightning. I can take your gRPC calls, I can deal with our macaroons, and it's the same calls, the same ports, the same everything. And we support several databases. Right now it's 4, but you can do whatever database, right? It's just some specific cases you have to do, like we are saving bytes, and this database uses this data type for this. So it's very easy, very scalable. And the new future is, whenever this is out, it's running, then I can do support, paid support. And Bitcoin Lightning users and companies are eager for support. I know like CTOs that shove money into current implementations, and they don't take it. Like, I won't support it. And I want to do the opposite. I want to do support. So I want to support them. I want to help them. And of course, I want to get paid for it, right? So demo time. I've been working on this for the past 18 months. And for the past 18 months, I've been working just with code. So I've been doing like I have 160,000 lines of code. I've been working on this mostly alone. I have some help from Richard Safier from PlebNet Playground. And he's done like some testing, unit testing. He helped on that, but mostly it's my code. So we're gonna run a demo here real quick. First, let's create we have a Polar, and we have C Lighting, Alice. I'm gonna deposit 1 million sats to Alice. So, and then I'm going to run my demo here. So I left memory and CPU there, just so you see it's a very small footprint. So I already processed, as you can see, 106 blocks, and it's on. So I'm going to copy, where is it? Here. I'm going to just copy this string here so I can connect easily. So I'm launching the Polar here for Lightning CLI. So I'm connected. You can see on the logs here, I have a ping service running. So I'm doing ping pong with CLightning right now. And now I'm going to open a channel from CLightning to NLightning. So we signed it, we did everything, and we have a channel. Right? So now I'm going to mine some blocks. So you can see I'm processing new blocks. I'm watching for a transaction. And now I have a channel open against CLightning. So it took me 18 months, 160,000 lines of code to get to this point where I can open a channel. So that's it. Thank you. So questions? I have 1.5 minutes.
Hey, check. Questions?
Okay, hey, how do you feel about .NET starting with the new Go and Rust languages like in the market?
Sorry?
.NET is a proven language that has been for a while, you know,
Yeah.
but it's losing a lot of positions against Go and Rust because they have like smaller footprint and their performance. How do you see that evolving in the future?
Well, I guess for what I'm doing, at least, it seems more scalable than Go and Rust. And like Rust, you have this safety net that don't let you break so easily. Like in C++, you can break memory all the time. In Rust, you have this safety net, but it's still like a hard language. It's very new, so there's not a lot of developers, not proven yet. And Go, I guess the biggest difference between .NET and other languages is that there's a way of doing things, if you know what I mean. Like, it's not written, but every single .NET developer learns how to do it this way. And so every application looks the same. So it's very, very easy to navigate new platform, new programs. So if a developer on a bank wants to have a try on implementing something for NLightning, it would be very easy for them, because if you look at this here, let me just close this and this. Everyone has a project pretty much like this. Let me try to, I cannot do zoom. Okay, but you can see I have several layers. It's a monorepo, but there's a lot of projects. And then I'm using DDD, domain-driven design, which is used by most .NET developers. And then I have a domain layer with all my, like, for protocol, I have all my enums here, I have all my interfaces here, I have all the value objects, so I have big size, I have Bitcoin network, big size dealing with like the numbers and how to convert the numbers for the protocol, for the transport layer. So a new developer will just come here and they know what to do. So .NET has this against the other languages. Every .NET software is built basically the same. So there's less friction, you know, for new developers to come and do something on NLightning. opposed to other languages like Go. Even people that knows a lot of Go, that has done it before, they try to navigate like LND, and it's very hard for them because it's another architecture, another footprint for the project, the folders, you know. So I guess this is the main advantage. For performance, it's pretty much on par with the other languages, but we have this on for .NET developers, so it's easier for a new developer. Is it? Oh.
Thank you very much for the talk. One question. Is it possible, like Core Lightning has this plugin architecture that anyone can basically add something new and run it on their own node? Is this kind of architecture also possible with your .NET implementation?
Yeah, it's very modular. And right now I have the signer. The signer is already outside of my project. So I have another project just for the signer. And I'm calling it here like the local signer. And it's fully compatible with VLS, the VLS interface. So I'm ready for VLS. If anyone wants to give it a go, just implement the VLS calls because the interface is very similar. And we can load stuff on runtime. So you can put on your configuration file. I already have space for like signer, use this DLL, use this library, and the interface would be the same. And I'm working on, for the CLI, loading, calling other software written in any language using IPC. So you can just put up a named pipe and we talk to me. So I'm ready for plugins as well. I think this is very important for the ecosystem.
Okay, that's all the time we have. We're going to take a quick 5 or 10 minute break before we start with the finalist presentations. So perfect time to get some coffee, some water. Be back in a couple minutes.
Thank you.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Presentations at the hackathon. Over the past 24 hours, or the 24 hours prior to this one, we had a bunch of teams working all night on some incredible projects. All of the teams presented in science fair fashion downstairs to the judges yesterday, and the top 6 teams have continued to work on their projects and will present on stage for you now. The judges were completely blown away by all of your projects, and it was a very tough choice to narrow down a finalist, but bit ado, we are here and ready to kick off the finalist presentations. Teams will have 5 minutes to present on stage. There'll be a timekeeper in the front row, so keep an eye on it. For finalists, I will announce who's up next. Keep an eye on the order. Like, you've seen the order in Telegram. So come up one team before your time is to go. So yeah, so the second team should go up right now. The first team is already ready. When the first team goes off, the third team should come up, et cetera, et cetera. When you come up here, you can tell us whether you want to be on camera or not. If you don't want to be on camera, we just will show your slides on the live stream. We won't put your face on. So yeah, so just let us know before you come up, or when you come up. Quickly to introduce a subsection of our judges. We had an absolutely star-studded panel of judges adjudicating your projects. We have 5 of our judges on stage here. We have Peter Todd from Open Timestamps, Jean from Zebedee, Evan Kalidas from Zeus, Felix from Electrum, and Eric Katifa from Bitcoin Design Foundation. So thank you guys so much for bringing your expertise in adjudicating these projects. First, I would like to hand it over to the first project, Obfusats. So if you want to, as soon as you're ready, you can come up and give it your all.
Yeah, thank you.
Mandal, you are on deck.
Got it. No, I don't think so. Just gonna. Yeah, got it. I got the, yes. All right. So, my little hack is called Obfusats, and I'm going to start it and let it run in the background while I describe what it is. Okay, so the segue from Elias's talk downstairs 10 minutes ago couldn't be better. This is actually a little proof of concept of mitigating exactly the traffic analysis on Lightning that he was talking about. So currently, all balances and channels are public on the Lightning network, which means that a dedicated attacker or entity could basically map out the network and follow payments through the network. And to mitigate this, I built this little tool that takes a Bolt 11 invoice and spreads it across, a couple of Cashu mints. So the idea here is to obfuscate the traffic analysis by creating a lot of traffic between the Cashu mints, within the Cashu mints, and externally to a final destination point. So think of it as an obfuscation mixnet, something like that. Spreads the payments. There's a lot of redundant traffic, and at the end, collects it in the end. For every round, this is basically round-based. Every round takes a time limit and spreads the transactions across this time. So it's very difficult to tell what's going on from the outside because it's spread across time. It's spread across at least 3 nodes. This is Cashu mints. And within the Cashu mints as well, to leverage the fact that the Cashu mint cannot see, the mint does not know if this is a payment within or externally. So by doing this, it's going to be extremely difficult to follow a payment, even if you had the mapping done. I don't think anybody has, but if they did, this would be a nightmare to follow it. While it is slowly bouncing this between the mints, it's also siphoning off some of the funds to the final destination, and the final destination would have been really nice to have Bolt 12. In the Cashu mints, it's unfortunately not ready yet, but with CDK mints, this will even work even better using Bolt 12 invoices between them and to the final destination. There is a mint scoring going on, so you can basically take as many mints that you like and reuse or use the best ones that are available. So I would really love to share this mint scoring. I haven't figured out quite how yet because, of course, this is super important to not share that you're doing this. That's the whole point. You want to obfuscate your sats. But somehow, you, at least for yourself, you do build a mint scoring to see what mints are reliable and can be used. This is done. This is finished. You can see it actually working. The last mint is slowly picking up the sats. I put in 2,000 sats, and this is just going. This is creating something like 14 Lightning transactions and 11 internal Cashu mint transactions. Good luck following that around. This is running 4 rounds of 30 seconds. Ideally, this would run like 10 rounds per each an hour, like across 10 hours, making the final analysis, I mean, absurdly difficult to do heuristics on. So this is basically just a proof of concept showing what could be done if Elias's talk were necessary right now. I don't think anybody is doing this, but if there were, this would probably mitigate a lot of it. This is, of course, not protocol level. This is simply just spamming traffic and making it really difficult to follow. Not sure if you have any questions.
Testing. 1, 2, 3. What are some other thresholds that you imagine the user selecting when you mentioned time rounds, so 4 rounds, 30 minutes. Do you imagine them being able to select, you want a maximum amount of fees or anything like that?
Yeah, so the more rounds there is, the more fees that will be paid, because the bouncing of the transactions happens within the rounds. So you could save on the fees having fewer rounds but longer distance, because you spread the transactions across time and randomize. So that would be probably sufficient, but you could also just spend some more on transaction and make it even more obfuscated. So you can select the number of rounds and the time of each round.
Great job, Obfusats.
Thank you.
Up next is Mandal. Nuts are pure signal. You are on deck. Come up to get mic'd up.
Yep. Let me just make sure all my stuff is good. Okay, can everybody hear me okay? I'll wait till begin. Okay, we have my stuff on screen. Ready to go? All right, so I'm Stephen DeLorme. My teammate was Connor Okas. We worked on a project called Mandal. Let's take a look at some of the users for our project first. So meet Elise. She lives in Berlin. She's all business in the boardroom, but she loves to go clubbing. Meet Bob. He lives in Atlanta. People say he's friendly, but a little quiet. Sometimes likes to donate to political causes that he cares about, though he tries to keep that on the down low. Elise and Bob like modern fintech apps. So Elise uses Revolut for peer-to-peer payments within Germany. She uses PayPal for international stuff. Bob, he's a total Cash App maxi. Now, Elise and Bob are not technical people. They do have a general sense that they want privacy. They feel like all their devices are watching them all the time, and they don't really know what to do about it because they're not technical people. Basically, Bob doesn't want to receive retribution for his politics. Elise doesn't want everybody to know just how many times she went to Kickoff Club this month. So I call this user group non-nerds seeking privacy. They're a class that I think Bitcoiners have neglected. And if you don't think this user group exists, take a look at this. Apple, NordVPN, WhatsApp, privacy.com. These are all targeted at kind of like mainstream users. And you might say, oh, well, they don't really offer the level of privacy they claim, but that's not the point. The point is that if you take privacy and you put it into a simple product people consume, they will use it. So our response has not been to package that mostly as Bitcoiners. We've given various solutions, various flavors of CoinJoin, and different ways of using Lightning. And you got to find the eCash mint you want to use. Oh, but it's just a privacy layer. Move it. It's just too complicated. It's not a product people can use. So how are we going to help Elise and Bob? So Connor and I have painted a portrait of this sexy fintech app called Mandal, and it's run by a trustworthy, licensed, regulated business. They use OpenID Connect to authenticate their users, and while the users of the mint are known, none of the activity that happens within the mint is known. They don't know who's doing what. So we also, have designed it to support Bolt 12 offers and BIP 353 natively, so every user can have a nice username and just kind of give them that experience that they expect from a modern fintech app. So the way it works is we started with product design in Figma, because when you look at all the most successful fintech apps in the world, they start with isolating a user, researching what their needs are, and designing it. From there, Connor took my design and implemented it using Kotlin multi-platform as an iOS and Android app. I set up a Cashu mint using CDK Mint D and LDK node. I used the Voltage Payments API to send MutinyNet Bitcoin into the node. We use OpenID Connect via a service called Keycloak, which is it's an authentication thing that you can self-host. And just as a proof of concept, we wanted to use just a list of bad guy emails that we want to keep out of the mint. So let's go ahead and take a look at a demo here. This is a video of the app that Connor set up. He's going to type in an email. We're going to have Osama bin Laden try to join the mint here. Osama bin Laden at gmail.com. What's going to happen? We're sorry. It looks like we can't serve you. You might just be on the OFAC list. Sorry about that, bro. Let's try Connor at spiral.xyz. He seems like a nice guy. He's probably not on the OFAC list. all right, welcome to the Mint Buddy. And then we gave him a BIP353 username, and he can send and receive Bitcoin privately and have a custodian from a regulated business. So let's go ahead and look at a Cashu Mint at a Keycloak server. So this is the Cashu Mint I set up. It's using LDK node. I set up some Lightning channels for it, and I started doing payments into and out of the Mint. That was pretty cool. Let's interact with our Mint via the CLI for a moment. So I'm going to go and say Mint info. Let's get some info about the Mint I set up. Oh, well, it supports NUT22, which is the blind authentication NUT. So this is an authenticated Mint, which means that if I try to actually send Bitcoin into the Mint, it's going to say, you probably can't see that because it's so small, but it says insufficient blind auth tokens. Basically, you're not authenticated. You can't use this. All right, so now I'm going to try and say, give me a login. Let me authenticate. Okay, that's where it broke. I shouldn't have shown you that. To be honest, I wasn't able to get to the Keycloak server and the Mint talking to each other in time. But once I figured that out, it's basically a Cashu Mint that authenticates its users. So let's just kind of look at some potential oppositions. It's not the cypherpunk dream. I get it. Nobody stopped working on self-custody and decentralization. But I think there are real people who would benefit from this. Banks suck. I get it. But maybe banks would suck less if there was more privacy and you could anonymously do a bank run. I don't know if this legally would work. It might not. I'm not a lawyer, but maybe this could start the conversation about how we can deliver these privacy products at scale. And look, KYCing people is bad. I get it, but a lot of your favorite Bitcoin startups, they have to deal with regulatory compliance. So anyways, that's all I had to share. Thank you so much. There's our source code if you want to check it out.
So now that you've got all of your users AML KYC'd, what's your plan for when the European Union inevitably goes and says, well, we did chat control, let's also do coin control?
Yeah, I mean, that's not going to work. They're going to take all of it.
Well, I mean, they obviously can go and get you to go change the source code in your app to go and do anything they want, just like they can on Signal.
Yeah, just like they can with Cash App, Venmo, PayPal, Revolut. I'm not going to make the claim that this is free from government tampering or free from government coercion. The main claim I'm making is more narrowly scoped, that if many people are already comfortable using custodial financial applications, for those people, could we give them a layer of privacy?
Well, I mean, let's be clear. What you're doing is you're going and making the argument, hey, we can go do this stuff privately with AML KYC, but of course we know where that leads. So this is why I'm giving you negative points, because it's evil.
Thank you. Thank you for the feedback, Peter. Any other questions? All right, cool. Thank you.
Great job, Mandal. Great job. Up next is Nuts Are Pure Signal. Glacier Wallet, you are on deck. Glacier Wallet, come up to get mic'd up.
Check, check. Good afternoon.
Yeah.
Okay.
See ya.
All right. There we go. Okay. Our project is Nuts Are Pure Signal. Can I get a show of hands? Who has ever used mobile coin payments in Signal? Wow. Well, I can tell you the payment still is in your receiver's wallet. They haven't used it. Okay. So we thought about why don't we just put a Signal wallet, a Cashu wallet using CDK into Signal instead. This is what the old UI looked like. We have old mobile coin wallet. It works, but to get mobile coin, you have to go to an exchange. It's a whole process. It's not really that user friendly. So we thought, let's use CDK like we do with everything, and give you a demo of what could be. Yeah. There we go. All right, so we got a native Android and a native iOS version right here. This is Tom. Tom developed the Android version, and he's going to show us what that looks like, starting with funding the wallet on the Android side. Yeah, so we have, we're going to pay a Lightning invoice right here. We should have a sleeper agent in the audience that is supposed to pay that invoice for us. Egge, please. Anyone can snipe it. There we go. Perfect. All right. Is it paid? Did anyone pay it? We're still waiting. Nobody paid it? I mean, we are rich. We have 20 sats. Let's just send the 20 sats. It's going to come in. So now we're going to send an amount from the Android to the signal on the iPhone. We've set up these accounts. This is basically mainnet signal. You can use this with any other signal account. And if you don't run this fork, let's see if the demo gods are with us. Does it go through? Okay. Maybe we'll try the other way around first. Okay, so we're going to send from the iOS to the Android. And you would do that from the old payments button. Let me give you a hand there. This is two different simulators. There we go. Okay, so this is what's supposed to look like. We can redeem on the Android side. It has been redeemed. And we should have the sats in our wallet. Came in right there. Oh, and there are the other 16 sats. Perfect. Wow. Yep. All right, and now we can do, for our last trick, a Lightning withdraw on the iOS side. We'll go to Settings and into the Payments tab. And there should be a Bolt 11 invoice in our pasteboard. Let's try it. Nothing? Oh, great. Copy that again over here. There we go. We want to save the children. Confirm. There we go. Sent. And if we go back to the wallet, and Cashu.me should have that registered in the history. There we go. Plus 10 sats. All right. And I think that it's going to be it from us. If the judges have any questions.
Have you done a pull request to Signal's GitHub repo yet?
We have not done that yet. I imagine they wouldn't be too happy if we slop drop on them.
I mean, if you change it so that you can use mobile coin into this, I mean, how can they say no?
I mean, I heard that the president of Signal is actually in Berlin right now. So she was supposed to be here. Meredith is her name.
Would the Signal license allow you to publish this to the App Store?
As far as we know, the Signal license for the app source code actually would allow us to. It's an AGPL 3 license. There is a different license for using their infrastructure, though. And this would not support push notifications if we were to publish this fork, sadly, because that has to use a certificate that only Signal has.
Awesome. Great job. Nuts are pure Signal. Up next is Glacier Wallet.
No camera. Yeah.
Rectbot 9000, you are on deck.
Thanks, bro.
Rectbot 9000, come up to the AV booth to get mic'd up.
Yep. Oh, fuck, what's it done? Need to change the display settings. Good afternoon, ladies and gentlemen. We are Glacier Wallet. Can I have a quick show of hands? Who here has sold Bitcoin and regretted it? Well, we have just the solution for you. If you have lettuce hands or any other problems with those descriptions, like high time preference, you can install Glacier Wallet. I've got a quick demo here. So we're going to generate a new wallet, and then we're going to connect to our reg test node. Now I'm just going to mine some blocks into my wallet, which of course won't be in the production version, but we just need to do this. So we've got 101 blocks there for the maturity. And so what we're going to do now is create a time lock transaction. So we choose how much we're going to lock up. So I'm going to select 1 Bitcoin. I'm going to go for a block height. So now you can choose any amount you want to lock it up for. We've got 6 blocks here, which would be 1 hour. Or we've got a super uber mega jigger long-term freeze, which could be either 100 years, 1,000 years, or 1 million years. Turns out these buttons don't work because the maximum time lock is, what is it, Pete? 11, I think it's 11,000 years. So sadly, the 1 million years button isn't going to work. Anyway. So I've created my time lock transaction here, but it hasn't been mined yet. So I'm just going to mine it into my node. So I click on it here. We can see it's been created. Details here. So I've got the push to the script key hash here. Now it's been mined. I'll just refresh my wallet. It should show as locked. So we can see now I've got some locked funds in my wallet and some unlocked funds. The lock was for 6 blocks, and it was 5 after that mine. So I'm just going to mine 10 blocks quickly so that we can see that when we refresh our wallet, it's now unlocked and spendable. So what I'll do is I'll create that unlock transaction now, and it will push that into the mempool here. And I click on it in the mempool very carefully. We see the details here. And you can see we've got the unlocking script here, CLTV, and then we should be able to mine that. And when we refresh our wallet, it is unlocked. User interface needs some touching up. So there we go. How to lock Bitcoin up using Glacier Wallet. Now you might be asking, if I locked my Bitcoin up for 1 million years, how will I know that I've got that Bitcoin locked up for 1 million years? And we've got James who's been working on the op return. So we're going to push in the lock transaction the op return with the unlock height into it, encrypted of course for privacy reasons, so that when you just need to back up your normal mnemonic words, and then when you load your transactions, you'll be able to refresh the op return, decode the unlock, and then check that that block height for the script to know that your funds are locked up there. And then we've got a quick demo of our.
What was that? Electrum plugin? Yes, of course we have an Electrum plugin. Kind of last minute, but with the excellent documentation that Electrum has about their plugins, I got an LLM to throw together a markdown file to be used as input for one-shotting an Electrum plugin, and it mostly worked. These are just screenshots. So this is on GitHub. This is based on the documentation. There are things in here that are not right, but I'm gonna run it against all of the Electrum plugins and then just update the code. Update the documentation. So it should be very feasible to do an Electrum plugin in a 2-hour hackathon. So these are not just screenshots. It's live on this laptop, and you can choose a block height or a timestamp. You get the public key. You generate an address. It spits out all of the debug info with the miniscript policy. I don't actually know if it works, but I'm pretty sure it should. I was able to send funds into it. I was unable to, or I didn't get around to retrieving them, and it's been published on GitHub. And thank you to our sponsor, Vibes Capital. Yeah. for the Signet funds. For the Signet funds. Judges, questions?
Did you mention you had some op return functionality?
Yeah, we didn't get to show it, but
just real quick.
Basically, works. Oh, sorry. Oh, actually. Yeah, we do. So here would be sorry. Does this have USB-C or is it just HDMI?
HDMI.
Okay.
Just describe it.
I'll try and set this up. If I broadcast it here and reload this page, I'll be able to see this fresh Glacier lock, and you'll be able to see in that Explorer thing there. There's an op return in the transaction that Spec funds, and that's what our app uses to loop over transaction history and figure out what funds you have locked. Great job, Glacier Wallet. Up next is Rectbot 9000. Floresta as a backend service for NLightning. You are on deck.
Put it right up on your mouth.
Try again.
Hello. Better. All right. Welcome, everyone. We were working on Rectbot 9000, an autonomous AI agent fighting for survival in Bitcoin markets. So the main question that inspired this project was, what could possibly go wrong if you attach a wallet to an AI agent, give it access to different tools and let it trade and fight for survival. This is Rectbot 9000. It trades leveraged Bitcoin futures with real sats, so it's not a simulation. It's real. And it posts about its journey on Nostr, so you can actually follow its progress. And it dies permanently if its balance goes to 0. The good part is you can prolong its life by sending some sats over. So how does this life cycle actually work? We funded the agent with some balance. The agent then analyzes the Bitcoin price data to find some trading opportunities, and once it finds them, it has a self-custodial wallet in his Albi hub, of course, and they move the funds from the self-custodial wallet to LN Markets for a 50x trade. The agent then monitors the trade, and as soon as the trade is closed, it's going to withdraw its profit to the wallet again, and then it's going to share its trade on Nostr. How does our tech stack look like? We have a Goose agent and different MCPs for interacting with external tools. So we have Albi Bitcoin Payments MCP for doing the payments. We have Nostra MCP for shit posting. We have Nell and Markets MCP obviously to go long or short. Memory MCP to remember its trade, and also, and that's quite exciting actually, we're about to release an open timestamps MCP, so every agent will be able to timestamp whatever they want, really. Our main programming language for this project was English, so we all of the agent stuff is just plain English and do this stuff, and here's your trading strategy in plain English, and yeah, it's amazing. What's on our roadmap? We're gonna improve this trading strategy, and maybe there's also a way to share the gains between users who try to fund the bot. But enough of the theory. Let's do some live demo and see how that looks like.
Test. So this is the website for the Rectbot. Unfortunately, the risk management daemon is failed to load, so the trades are really, risky. Its mission is to trade Bitcoin, but usually the outcome is failure. And what's cool about the website, you can there is a ASCII balance chart. There's also you can also tip the bot with ASCII QR code.
So pull out your phone and prolong its life, please.
For some wallets it doesn't work, or some phones, but for some phones it works. So it's that's the trade-off. And yeah, let's now go to the Nostr. We can also show the trades maybe quickly. It also loads trades from Nostr.
Yeah, let's quickly show the QR code for those who want to do good, but you will also have the chance to see it on the website.
We need to go because 45 seconds. Let's go to the Nostr profile. It's down. The link is down. Yeah. Whatever. You have it. You have it next.
Just a second. All right.
So the bot posts every open trade and close trade on Nostr, and depending if the previous trade was good or bad, it also changes the avatar. So the avatar reflects the mood, and now it's angry because it lost lately. Yeah. And in addition to posting trades, he also shit posts like random Gen Z stuff of eating circuits, stuff like that. And also it replies to users on Nostr if you reply to him.
So if you want to get roasted, tag him.
Yeah. That's it. Thank you.
So I'm very concerned that when this inevitably makes enough money to go and take over the world, our archival record of the Nostra posts won't be open timestamped, allowing us to go determine when exactly humanity failed. So did you actually get around to open timestamping Nostra using the Nostra open timestamps?
So we did implement the Nostra NIP03 to attach an event at the daystamp, and also the open timestamps MCP. We were in the middle of integrating everything together to work when we had to rush here. So yeah, but it's in progress.
In progress.
And also, we thought about actually the nodes disappearing from the relays. So we are also thinking maybe include the nodes in op return, maybe.
But and then there's a second thing that I think is really important here, which is for the scenario to become true. Did you add the ability for it to go purchase VPN servers on its own so it can run independently of you?
Not yet.
It'd be good second effort.
Yeah. Absolutely.
Great job, Rectbot 9000. Up next is Floresta as a backend for NLightning.
No. Oh, sorry. Jump. You can go? Yep. Cool. Okay, hello everyone. This is Floresta as an NLightning backend. Why do we need it? So Lightning needs access to blockchain data, such as blocks, transactions, and everything else. And this requires a Bitcoin node running all the time while your node is running. And this is resource intensive, and it's hard for non-technical users. So when you account for the Lightning and Bitcoin node, it can get huge on resources because it's a couple terabytes, right? And then most users end up using centralized solutions, meaning it hurts their privacy. The server can see whatever they're doing. Their security, because the server can lie to them about blocks or transactions. And it hurts decentralizations, because there's just a few nodes serving all of this data, and they can become very powerful. Ideally, we'll have a solution for better security trade-offs. And on mobile, it's pretty impossible to do an IBD. And there are protocols that can offer better security even without IBD, but we want IBD. So NLightning is a .NET implementation of the Lightning Network. It's portable. .NET can be compiled to several architectural OSs. It's lightweight. The memory footprint is very small, and it's managed by the runtime. It's modular, so it's very easy to navigate through the code by new developers. And it's using a battle test design. And it's extensible, so it's very easy to write and plug new software into it. And we have Floresta, which is a Bitcoin client. It offers better privacy and security, and it's lightweight. So it can operate as a fully validating node. And it uses about 300 megabytes of disk and 200 megabytes of RAM on mainnet. So it successfully run on mobile during 2024 SciTech, and it uses compatible block filters to find UTXOs on the network, just like Neutrino. The solution was integrating Floresta with NLightning. We have an extremely lightweight and performatic node, can run on whatever device you have. It offers better privacy, since all the chain operations are done locally, and better security, because it's a fully validating node. And all of this without requiring research or technical expertise from the users. What we need to do for this work, both Floresta and NLightning is very modular. So it was mostly a drop-in replacement, like from Bitcoin D to Floresta on the NLightning side. Small changes we had to do on Floresta's RPC to find blocks and get the block height, the current block height. And we had to do a translation proxy from RPC 2.0 to 1.0, because I'm using on NLightning 1.0 currently, and Floresta was 2.0 only, so a small proxy layer. And then we had it working. We don't have a demo right now because it's like 10 windows running Bitcoin Core, U3XO, and everything else, but we showed on the first part. So now with this, we can have lightweight clients with Floresta as a backend on NLightning. And in the future, we would integrate this on a mobile Lightning wallet like Zeus. So you could be running NLightning and Floresta, like a fully synced on Zeus wallet on mobile. So that's it. Thank you. Questions?
All right, so we can compile NLightning down to Android and iOS?
Yes.
All right, that's exciting. When, 2 weeks?
Well, maybe 3. Well, actually, NLightning is almost on par with the Spec, the boats. It's just missing 2 boats. We are 75% compatible. And Floresta is already running, so it's up to me to get to there. So soon, TM.
And then why did you guys did this backend for NLightning and not the other implementations like LND, for example?
Oh, it's modularity first. The other implementations, we try it at first to look at other implementations. The guys have experience with LND, but then it's very hard to navigate the code. Like, I want to change the backend. Where do I go? So it's very hard to navigate, and NLightning is just finding nlightning.infrastructure.bitcoin, and then there's a plugin for the backend. So it was very easy to just do it. So we had 0 changes on NLightning, just a small change on Floresta and the proxy layer.
Great job, Floresta, as a backend for NLightning.
Thank you.
All right, and that concludes our finalist presentations. There's going to be a 15-minute break. Both stages will resume at 2:45. So the schedule says 2:30. Both stages will resume at 2:45. Judges, please come downstairs and meet me in the judging room. Make sure you come back here at 4:45 for the Hackathon Awards and closing to find out who wins. All right, thanks.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin.
It's about that time here at Bitcoin Plus Plus. Are you ready? Are you ready? You're ready? Presenting Splice, Splice, baby. It's Dusty.
Hey. Thank you for that delightful intro. Let's go. So I'm Dusty. I'm a Lightning protocol developer. We're working on splicing is the big thing. Oh, there it is. Yeah, that's me. A little about me. I've been working on Lightning for a few years. Splicing was the big first project I took on, and it turns out it was a big one. That's actually a bit of what I want to start with today, is the history of splicing. I've been trying to get a comprehensive history of the process to kind of give you context like what has been going on with this. So back in 2019, Rene Picard actually presented a whole thing on splicing, which it's interesting watching the video. I'm going to try to play a little clip for you here, but it probably won't work, but we'll try. It's just interesting going back in time, like how people thought about it back then. So we'll give this a try.
Off-chain, you can just splice something in. It's like an on-chain transaction that just changes something. So I thought this is really cool, and the guys from Lightning were like, yeah, we're working on this. And I thought this would be so difficult.
And then we'll just skip ahead to the last part of the talk over here.
So that's basically my answer to we can do a lot of stuff, right? But depending on what we do, it has severe consequences along a lot of other stuff on the protocol. And that was for me a thing that I needed to learn over half a year, three-quarter of a year, like for a long time. Because I was just drawing these pictures and be like, hey, I solved splicing. Why was it so difficult for the Lightning devs to do that? And yeah, I mean, now I know. So
try mixing in the backwards compatibility with nodes that might or might not have upgraded yet, and it gets really weird.
Yeah.
So yeah, that gives you some context of the time. I think people started with this sort of optimism that, oh, we can just do splicing. We'll add it to Lightning. What's the big deal? And I think everyone slowly kind of learned, wait, this is actually a really complex problem. And Rene, which if you watch that talk from Rene, covers it quite well. It's literally him going with the audience, talking about what are some ways we can do it, and him explaining why they don't work. Okay, so that happened in 2019. And then a couple years later, the first Splice proposal was dropped. This is a Spec proposal. So this is like where these sorts of ideas usually start. It got put into 2011. Got a picture of it here. So that happened. And then I came along and I was like, oh, I should do this splicing thing. And just like Rene in the beginning, I was like, how hard can it be? So I was like, oh, I can come do this. Why not? You know. And then here's a little speech bubble about my thoughts at the time. You know, like, oh, won't be that bad. And then I upgraded to this thought. Then that upgraded to this thought. And then eventually I did get there. And then in 2023, oh, thank you. Got splicing working. It was very exciting. These are my excited emojis. And that was a big deal for me. I felt very awesome about that. And I mean, it is awesome, right? So that's sort of in the past. And then 2004, Claire, they implemented and released splicing. So that was very exciting. Now we have 2 implementations doing it. So congrats to T-Bass, who's not here, in honor of him. And then recently this year, we got to a thing called interop with the Claire and CLN. And in the lifespan of a Lightning feature, this is sort of where, this is like the endpoint. It starts over the proposal, and then you succeed when you get to the interop spot, and then it goes officially enshrined in the spec. So what is interop for those that don't know? Basically, you have to have a channel between two different Lightning implementations that can have that feature running between both of them. So if Eclair does splicing slightly differently than CLN, then they're not interoperable. You haven't accomplished so-called interop. So interop's done. It begs the question, is splicing done? Like, are we just done with all this? Can we all move on and, I don't know, take a long vacation? No, good answer. Just to kind of like high level it, so what we have now is Core Lighting definitely has it, Eclair has it. LDK, it always seems to be like, just tomorrow. It's coming really soon. But no, they are working very hard on it. I don't know what's going on with LD. Maybe they're working on it, maybe they're not. I hear different things. But because splicing is a two-party feature, this means that both sides of the channel have to support splicing to get any of the benefits from it. This means that we need more of the network to adopt splicing for its impact to really be felt. So it's really critical we get more of the network having splicing enabled. Because if one side has it and the other side doesn't, you can't splice. Yeah, that covers that. Okay, so what's next? What's coming up in 2020 something? Exciting things. You might ask, what are you going to do now, Dusty? Thank you, hypothetical inquisitor, for the question. Okay, it's a great question. Let's talk about the future of splicing. And this is something I'm like really excited about. Like there are so many things that are like possible once splicing is there that I've been eagerly waiting to jump on. Okay, but to start for context, what we can do now with splicing is primarily these two things. You can take a Lightning channel that's already there and you can add funds to it. Move your chain funds to Lightning. Boom. You can also go the other way, take your funds out of a channel, move it to your chain funds. Does everyone understand this? It's a lot of quietness. Yes, thank you for the confident yes. And importantly, this is all without pausing the channel. So like a typical use case would be somebody has a Lightning routing node or they're trying to become a big router, and they make like 20 channels, and then turns out 2 of them or 3 of them are very, very highly used and valuable, and like 10 of them don't even get used. So their liquidity is better put in those high-value channels. So you'd want to splice funds out of your low-value channels and then put them into your high-value channels. But you have this problem where without splicing, you'd have to shut down those channels and reopen them to change the amounts inside them. And you don't want to do that for your high-value channel, right? This is your moneymaker. You want to keep it buzzing. So splicing allows you to do it while it's sort of in flight. And this is really awesome, but it's also like old news, This has been done. Okay, so this is the stuff I'm getting really excited about. What can we enable in the future? And just going through some of these examples here, we have moving funds directly from one channel to another. So here we're talking about taking funds out of a channel, now you have it, then later on adding it to a channel in 2 steps. But there's no reason it can't be one step to directly move funds from one channel to another. You might also want to move funds out of a channel and then create a new channel with those funds. And this is deceptively powerful. Like right now, Lightning operators, they keep a reserve of on-chain funds and a bunch of channels in case they need to open new channels. They got to have funds ready to be able to deploy to new locations and channels and move things around. With splicing and moving funds from an existing channel to make a new one, they can keep all their funds in channels, and the moment it's needed, splice it out of the channel and make a new one. So this means less dead liquidity, less dead capital laying around. And that's deceptively a big deal. All right, and then we have, also, this is something, Renee, if you caught a little clip there, he mentioned, which is paying a chain address from a Lightning channel. So this is the idea of, let's just say you had all your Bitcoin stored in Lightning, and somebody wants you to pay on chain, what do? Well, without splicing, you just kind of can't do it. You close a channel, something like that, right? You're forced to keep some kind of reserve on chain for that. With splicing, you can directly pay on-chain to on-chain addresses from your Lightning balance. So this is actually quite a big deal, I think, as well. A lot of these splicing is full of these like deceptively like, oh, okay, that's just a thing. But then you really think about it and you realize this enables a whole different. This can reshape the way that we do all payments, including on-chain payments. So adding funds to a channel from external chain funds. This is another one of those things where almost everybody who runs a Lightning node they take their Bitcoin, they move it on-chain to their Lightning node's on-chain wallet, and then from there they move it into a channel. And that middle hop is totally not needed. That's like totally wasteful. And yet that's what everybody does today, right? So that's another thing that the tooling here that we're making can fix. Just pay directly from wherever your cold storage is, or wherever you're storing it, directly into a channel. There's no reason it's not theoretically possible. And with this splicing stuff I'm talking about, we're going to be able to get there. Okay. And also opening new ones. So opening channels, adding funds to it, that kind of thing. Okay, that's the primary category. Now we're going to get to the complex category. These are the complex things we're going to be able to do with splicing. And this is where it starts getting really unwieldy really fast. But it's all the same stuff. So moving funds from many channels to many channels. So let's say you have like 5 good channels, 5 bad channels. You want to move funds out of all 5, your bad ones, to your good ones in one go. That's something that we want to be able to do with splicing. And it's possible in theory, but it is so difficult to do. There ain't no one doing it except for like that one unit test I wrote that does it. Opening many channels at once is an obvious one, right? And this ties in with Lisa's dual funding work. But the ability, I just want to open up like 5 channels, 1 transaction, go. That's always impossible in theory, but that's something I'd like to make just a normal occurrence, easy to do kind of thing. Closing a channel, moving funds to a channel. So this one is you think it'd be in the primary list, but turns out closing a channel and using those funds for something is quite complicated because you don't know when the channel can close. You might have a pending HTLC payment on that channel. Maybe that expires in 2 weeks. So if you want to close the channel and use those funds, you have to have logic that goes over time and waits for that the channel to be closable, and then perform some actions. This is actually deceptively complicated, even though it's often the first thing people ask for with splicing. One of the first things. Okay, and then, so again, we have just closing many channels, is extending upon that into a new channel, and basically doing all of these at once. All right, have I sufficiently confused everyone, or how are we doing? Everyone's following? Okay, great, thank you. Okay, and then there's one, we're gonna go into each of these in detail, so you don't have to memorize them, but just wanna give you a high level of what we're talking about. And then there's this bonus category of like, if splicing really does well, what are the things, like the stretch goals we could finally get to? And I think it'd be awesome to integrate splicing with things like pay joins and coin joins and basically all chain traffic. So like if you're doing a pay join now, you're trying to merge your transaction with other transactions with a merchant to kind of hide them. Why not merge it with a Splice transaction? And the splicing infrastructure is already set up to handle that. Splices today are actually joined across multiple Lightning nodes. So there's a hypothetical world where these are actually merged into splices. There's another hypothetical, you can take this to its end conclusion. There's a hypothetical world where every block is one transaction. It's one big splice join. And everybody's stuff is inside of it. So those are the bonus goals. You know, we get it one day, you know. Okay, so in looking at all this stuff I want to do, get going with splicing, there's sort of this development question. Like, do I go through and take each one at a time and just like go a little bit more complex and solve them and build upon it? Or do you flip it around and go the other way? Like, what if I just solve the most complex use case first and then went back and solved the easier ones? And I think, so the long run approach, there's some pros and cons. So the pro is you can build a system to handle any complex splice, which, you know, that's useful. The con is it's a lot of work. And building a system to handle every kind of splice possible is sort of a gigantic, you know, Rube Goldberg machine that you got to build. And it has to do it perfectly and not, because this is people's money, right? You can't mess it up. And there are a lot of types of ways you can do splices, so that's a big con. Now one of the pros is that if you build the mega machine, then you can just, if you want to do a simple feature like cross splice, you can just ask the mega machine do a little cross splice, and now that's like a 2-liner as opposed to its own implementation. And it's all rather complex to accomplish, but I decided in the long run this is the better way to go. And this is why we're starting with the complex solution. It's not that we're forgetting about all the nice simple things. I'll go back a little bit here to like moving funds from one channel to another, or all those other things. We're not forgetting about them. We're just skipping over them to the complex stuff. And then once we get that done, that stuff will get really easy. That's the idea. So I devised this thing. I know there's a lot of languages, and sometimes people are like, oh, what, another language? Which is fair. But I devised this new syntax for a Splice script. And it's not really a language. It's more just a formal way to write out what you're trying to do with the Splice. And the goal is pretty simple, a syntax to describe every possible kind of splice, which is easy to write, but that's, there's a lot of details that come after that. A list of some of the complexities to give you a sense. I won't read them all, but we've covered a lot of these. But there are a lot of things you want to be able to do, right? For it to be useful, it has to be easy to understand. For a couple of reasons, like that, the more simple Splice script can make doing complex splices, the more users can do more complex stuff. Like right now, if you wanted to do some mega splice with 5 channels and 5 on-chain addresses and some other things, you have to manually keep track of this state and manage something like, I don't know, 60 different PSPT states, perhaps more. It kind of explodes. It gets really complex. But by making it simple to do that same kind of operation, you enable users to do more. They can actually do more complex things because you simplified this pain point, right? So that's the goal. And on top of that, do I cover that here? Yeah. On top of that, it also allows you to more easily audit what's happening. There are some ways that you can do a splice, and if you're not careful with where you move PSPTs around, have your funds stolen. So like people often don't think about this trust model, but if I have a PSPT, and let's say I like uploaded it to a website that like changes the PSPT from version 0 to 2, and they give me the result, that website could maliciously add outputs taking all your money. And if you're not careful, like that kind of thing can screw you over, right? One benefit of using a Splice script is those types of vulnerabilities just can't happen. Just take all those problems away. And also, there's ways you can also shoot yourself in the foot, like accidentally pay too much in miner fees, things like this. That all can be solved by this Splice script. Okay. Before we get there, any questions so far? Does everyone follow what I'm saying? Everyone's nodding their head? Okay, great. Let's go through some examples. And this is your technical warning. If you don't like looking at technical stuff, shield your eyes or something. But we'll come back for you. All right, so going through this first category, what does splicing enable now? Adding funds to a channel, taking funds out of a channel. These are sort of the splicing basics, right? And in Splice script, we make them look like this. And the idea is these are channel identifiers, so A338 AEF0 is actually the first couple of bytes of a channel identifier. You can put the full channel identifier in there too, but it looks prettier this way, and it can auto-complete it, no problem. And so the top one is, we'll go through these, and this gives you a visual sense, we'll go through each one. So here's the first one. If I want to splice out some money, let's say I have a channel, I want to get 10,000 sats out, simple, easy. Write this little script, channel, arrow, 10,000 sats. Pretty straightforward, right? That's the idea. Let's say you want to put 10,000 sats into a channel, splice in, just flip it to the other side of the arrow. 10,000 sats going into the channel. Make sense? Great. Great. I love your answer to my questions. I appreciate that. Okay, so the thing is, this script actually is kind of a lie. That wouldn't be possible, because this would build a transaction that invents 10,000 sats from nowhere and puts them in a channel. So in reality, you have to get the sats from somewhere. So there's this other magic operator in there. It's called the wallet, and it just pulls from your Lightning node's on-chain wallet. Like, all right, pull out 10,000 sats. That puts it in this kind of usable state, and then 10,000 sats go into the channel. Make sense? We're gonna get more complex from here. So if this is confusing, stop me now. Yes. So actually, it's a great question. The question was, can I do an external wallet? This is how you would do an external wallet. You would build this script. It's going to give you a PSPT, being like, fund this PSPT. You go fund it with your wallet, bring it back, and then that's how you would externally fund it. That's a great question. Okay, and this is also a lie. This won't work either, because this will build a transaction with no fees to the miner that will be paid. So you actually have to add those, and there's this nice little fee operator, which what it'll do is it'll actually calculate the correct fee rate, and it'll add whatever fee you need. It'll deposit that withdraw it from the wallet. So it'll add the right amount to go. You can also do it the other way. You can take the fee out. So in this first example, we're taking 10K from the wallet, and then how are we on time? We got like, that's ticking down. Okay, I got to speed up. All right, thank you. So, this takes extra funds out for the fee. This one takes it, reduces the ending channel balance by the fee. So there's just different ways to do it. We're going to start going a little faster here. You can splice out here. I want to splice at 10,000 sats and take the fee away from whatever goes to the wallet will actually be 9,000 something. But okay, that makes sense. I don't have to go that fast. We can just pace. So back to the primary category now. So these are like kind of the mid-level stuff we want to add. What would those look like in a Splice channel, in a Splice script? And those would look roughly like this. This gives you a visual sense. We'll go through them individually here. So if I want to do a cross splice, I want to take, this is taking 50,000 sats out of this channel starting with 833, and then it's moving all of that money, 100% of whatever's there, over to 07B. And there's this cool little thing in there. If you do a percentage, then it'll actually take the fee out of that for you. So you don't have to put these fee operators up there. Let's go. He said beautiful. Appreciate that. So this is the same thing. We're making a new channel. So here we're taking 700,000 sats out of this 833 channel. And this is a node ID, the prefix for a node ID. So some peer we want to open a new channel with them. So this is how we splice funds out of a channel and then create a new one with it. And this is how we would pay to an on-chain address. So this takes 10,000 sats out of the channel 833, and then it sends it to this address, which is actually one of Satoshi's addresses. Does anyone know why this script might not work, or won't work actually? No fee? Yes! Ah, you guys are listening. I love it. You need to add a fee. So yeah, add a fee. That one's good. We're going to go a little fast here. This is an external one. The question before the external funding. This is how we would make an externally funded, just straight. I want to get funds from an external wallet. Make a new channel. Boom. Simple. Okay, now we're getting to the complex stuff. So the goal with this is to handle complex splices, but try to make it as simple to read and understand as possible. And I think I did pretty good. So this is like an example of what some of that stuff might look like. We'll go through these individually. So this is moving funds from many channels to many channels. So here we're adding in some percentages to show you some more of the syntax we're going through. We have two channels, 833 and 339. I want to take half the funds I have of each of them, and I want to dump the total amount into these other two channels. So this is how we're taking a splice between two channels, splice out the funds, and splice into two other channels in one go. And obviously you could do 2 or 3 or 5 or as many as you want. And what the asterisks do here is they just divide up what's there. So it's like whatever funds are there, they just divide it evenly between all the asterisks. So we could also do this thing. We say, okay, I want to get 700,000 sats out of my wallet, and I want to open 3 channels and just divide the sats into all of those channels. So the idea is this is sort of also easy to understand and do. And we could also say this is the same example, but we're specifying the amounts. I want 100K to go to that one and 300K to go to these two channels, kind of thing. So that's the idea. And then we'll go through this one, closing a channel, moving funds to a channel. This is that fun one where you could take a channel, close it, splice all of its funds into another channel. And we got one more here. Closing many channels, moving funds to a new channel. So this is basically, it's the same idea. We're just showing what we can do with n channels, basically. This is 3. Close 3 channels, put in a new channel. You can do whatever numbers you want. That's the idea. And just for fun, I probably shouldn't have included the slide. But definitely avert your eyes if you don't like technical things. I have an unnecessarily complex example that does a bajillion. It kind of touches every feature almost in the whole thing. And actually, this is ripped from the compiler, unit test. So this does a bajillion things on purpose in very wonky ways. And then it compiles down to this, where it'll actually tell you what it's trying to do. Okay, put these sats here, put this into the wallet, all that fun stuff. So if you want to challenge yourself, try to figure out what that is. Go. No, just kidding. Okay, the technical warning is over. No more complex examples. Thank you for bearing with me through that. Do we have any questions about Splice script? Yes. So work with a check command, like make check. Oh yeah, there is a check command. So there's a dry run. That's a great question. So the question is there a way to check if the script would work? And it's a great question because there's a lot of levels to that. There's a dry run check, which is essentially what this is. Like, does the script actually, do the numbers add up? Is this a script that could be real? And this is actually the result. Taking this to the dry run, we get this, right? And that'll fail if you're like, hey, I want to withdraw 10,000 sats and move them into a channel that's with 100,000 sats. Like, well, you're missing 90,000 sats. Like, those types of errors are caught on a compile phase. But there's a different kind of error that is like that if you're pulling, I want to take 100,000 sats out of this channel and move them. That channel balance can change any time. So like literally as you're typing it out, someone could route some fees through it. Now you don't have 100,000 sats anymore. So these scripts can fail like further down the path, right? And there is actually like a wet run, it's mostly for development, where you can have it go all the way to where it would have done the splice and then abort. But you shouldn't really use that because it pauses your channel with STFU essentially. And did that answer your question? Awesome. Okay, we all get Splice script done. Any Splice questions? Forever hold your peace. Great. I assume you all get it now. It's simple, right? It's like not that complicated. Like how bad could it be? Okay, so in summary, just to reiterate, the goal here is to create a simple syntax for the creation of complex splices. And the goal is to make it easy to create, simple to audit, and get more people doing it. Because I think like with splicing being here, people kind of know it exists, but not people are like using it. And I don't think many people at all are using the advanced possibilities. And that's sort of my goal, is how do we get more people being able to use it for more cool things in their own lives. And it adds security at the same time, so that's cool. So the roadmap for me here is I'm going to build the complex thing, and then, this is a reiteration, but I just want to really drill it in. I'm building the complex thing so that we can get the simple features done more easily. And it's sort of this development philosophy that I've been like increasingly growing more on, is that if you take the time to really build something, a key component, as high quality as you can, and really round out the edges, make it extensible in ways that maybe you don't even need to use, but can make it work in all of those processes, then it's like this positive virus that like spreads awesomeness around everything that touches it. Like tools that use it become better without trying as hard, right? And code that uses it becomes better. And I think that sometimes it happens where a real gem gets placed in some code, and you can just kind of feel how it makes everything better around it. And that's the standard I'm trying to hold myself to with this one. So that is my talk. Thank you for coming. Are we doing any questions? Yeah.
When? As in which release?
When is Splice script coming? So there actually is an experimental version of Splice script. It's like, I'm not even sure to call it beta, it's like alpha, that is hidden in the core Lightning under like a dev Splice command. But you can play with it now. A lot of things don't work yet, like cross-channel splices don't work, among many other things. So it's sort of like an MVP, and I'm starting to build out upon it. One of the weird things is all this fee stuff. Where did the fee stuff go? You'd be shocked how complicated doing fee calculations are. Like just to kind of braze over it for a second. Like with a wallet, if you need more funds from the wallet, sometimes it means the wallet has to grab an extra UTXO, which then increases the size of the transaction, which increases the size of the fee you have to do. You get in this sort of infinite loop. Wallets have been solving this problem forever, but turns out I have to solve it again to make this thing work in a totally different way. So, any more questions? Yes.
Yeah. I can only speak for myself, but for me, splicing is the most important feature in Lightning. And you were saying on the roadmap, like coin join and pay join, so that's next level for Freedom Tech. So, but my question is, currently, in my humble opinion, there's only Phoenix wallets. That's the only wallet with a good UX using splicing. So my question is, when do we finally get competition in splicing?
That's a great question. Thank you for I agree, splicing is very important. Thank you for saying that. Phoenix is awesome. For those that don't know, the Phoenix wallet used to so it's a wallet you use to do Bitcoin, right? And you connect to Phoenix's servers, and they fund Lightning channels directly on your phone, so you actually hold them. And for a long time, when you needed more liquidity, they would open new channels to your phone. And I saw this one guy, you can look in the settings, he had like 15 channels to his phone. It was wild. And people probably had way more out there than that. And then, you know, when TBAS got splicing going on Phoenix, everyone's channel quantity went to 1. And at the same time, TBAS announced, oh, fees are now half off on Phoenix. And by the way, I think he saved more than half on fees, so his profit margins went up while also charging less for the service. And Phoenix is like probably the best example of a really awesome use of splicing today. I completely agree. Win competition? I don't know. Someone should go do it. I don't know. Use SpliceScript. Let's go. Thank you.
I have one final question. Splicing is like really nice for like cross-channel splicing to move liquidity, but that of course produces a huge chain of transactions. So I mean, this could be optimized when you have like a channel factory. You know, there's this trend of doing this with Arc. Any ideas of how complicated it would be to use your scripting language and expose this to an interface like this
for multi-party channels?
Yeah, and channel factories where all these channels are basically VTXOs in Arc.
You know, you could adapt to SpliceScript. You just need to have more peers per channel, right? You could. I hadn't thought about it very much, but that's probably something. It probably would help in handling complex. You know, maybe one day SpliceScript will be so sophisticated you could implement Arc inside of it. I don't know. But that's a great question. And
let's hear it for Dusty. Thank you.
Thank you. Thank you.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Who, in a nutshell? Please give a very warm welcome.
Test. All right, let's get started. Thank you for coming. You guys are amazing. I've been enjoying this conference a lot and happy to give this talk on a Sunday and see so many people still up here. So I want to talk about payments and Cashu and what we do, the interesting things we do with Lightning, and hope to also nerd snipe a couple of people to help us solve these problems that we're still working on. All right, so this is my table of contents. I'm going to talk about eCash and then about Lightning. I will give an intro on Cashu, which is, you know, many of you might have heard already the basics, but I kind of need to revisit them to get everyone on board, and then we'll switch over to Lightning. First, Cashu. So the Cashu protocol since 2023 has seen crazy adoption with all sorts of different wallets being built and Mint implementations in different programming languages. There is a lot of activity going on Nostr, and there are many services on the web that use Cashu. This list is not really up to date and also by absolutely not comprehensive. So if you want to see the incredible amount of different projects building with Cashu, you can go to awesome.cashu.space at least, or search for the awesome list on GitHub. So I want to give a brief timeline of the different implementations. Again, this is just a very small view of what's actually happening, but it'll give you a sense of the progress that we have made so far. So in the beginning, I've released Nutshell, which was a Python implementation of what's now called the Cashu protocol. And I made the first UI wallet called Cashu.me, which is a web-based PWA. Then another crazy person joined me. This was the first person who contributed externally to the project. With a project called Nutstash. And Nutstash was by Gandalf21. And Gandalf formalized this wallet that he built, and eventually this became Cashu TS, which is a library that still powers most of the UI-based Cashu wallets today. and is currently maintained by a bunch of developers together. So the team around Cashu TS is still growing, and we're putting out this very simple and stateless library that many people use for their wallets. And this has become now Coco, which is a stateful wrapper around Cashu TS, which basically helps you to manage state of your wallet and also brings the database so that you don't have to implement any of the intricacies of handling the wallet states. So Coco makes it extremely easy to use Cashu TS in your web-based wallet. It's truly simple. You should check it out. It's basically just receive, send, that's it. And then there were a couple of Mint implementations that popped up early on. So first alternative Mint implementation, or I should say the second one, is Feni in Go, and a couple of others came that stopped development at some point, and then something called Cashu RS came, which was a Rust implementation originally put forward by the Simple Kit, who is still developing, an active developer of Cashu. And this became CDK eventually, which is the Cashu development kit that we use for many projects today. I highly encourage you to check it out. It's a super robust library and standalone binaries. And we've been currently working hard on building bindings from those for mobile wallets. So you can use CDK in your Kotlin or Swift iOS app, an Android app, or on the web. And it's similar to Coco. Both of these projects are stateful. So they do everything for you. You don't need to understand the protocol or what's happening behind the scene, which was kind of our design goal here. You know, moving on, there were other Mint implementations that came. So we had so far 3 Go implementation, one of which is still alive, Nutmix, still developed by Leo. And a very popular wallet that came was Enuts in the beginning. Enuts used Cashu TS, but then died, and currently it's being resurrected. So Enuts is coming back, and now this time it's built on Coco. Many other more wallets that I could mention that have been like an integral part of the ecosystem, really great wallets that I urge you to check out if you want. Minibits, Macadamia, Koinos, and Zeus. We've seen also a great talk about Zeus yesterday. So a few words on CDK. CDK is a Rust library. It's for mints and wallets. It comes everything in a one package. It can be used as a library or as a standalone application. You can run it on your server, or you can run it as a CLI wallet. So we've built a CLI wrapper, a very thin wrapper around the library, so you can just use it, or you can include it into your own projects. The bindings for Android, iOS, and the web help you to implement this into mobile apps, and Flutter and Go is also being worked on right now. And then again, Coco, TypeScript baby. You can use it for React Native or for web apps. It's very lightweight, and it's the stateful wrapper around Cashu TS. And we say it comes with batteries included. All right. Quick refresher on eCash and how it works. So first of all, we start with blind signatures, as everyone probably knows here. Blind signatures are a way to sign a message that you don't see, and then you need to be able to verify that signature once that message is presented to you. The famous example of carbon paper that you've probably heard of. So you sign the message from the outside, and you don't see what's behind the paper, and then once someone opens the paper, you can see your signature. And the flow is the following. So we have Alice, the user, and Bob, the mint, and then Alice takes some data and encrypts it. So that's the blinding part. And then Alice sends that blinded message to the mint, and the mint signs that. The mint returns that, and then Alice can decrypt that signature and retrieves a blind signature. And then together, this piece here, the encrypted message and the decrypted signature, those together are an eCash coin. And when you want to spend it, Alice sends that packet together with the signature to the mint, and then the mint verifies the signature. So if you're a mathematician, you might like these kind of diagrams. I think of this as like 2 spaces. There's the visible space and then the blind space. And then you start here with a message, and you blind it. You lift it up into this blinded space. Then we sign it in that blinded space, and then when the mint returns you this object, a blind signature, and you unblind it to get an unblinded signature. And together, those two are an eCash coin. So let's do some math. I want to show you exactly how it works and also show you that it's kind of very simple, at least in terms of like the number of lines of math that you need to know about this. So first of all, Bob creates public keys. We have I times, like I is the index for the keys. We have n keys. Each key corresponds for an amount for a coin that Bob supports. This could be like 1, 2, 4, 8, 16, and so on. And generates these private keys, small k, and public keys, big K. Alice now comes and wants to blind. So what Alice does is picks a random secret. This is the secret message. And when we put it in a function called hash to curve. Hash to curve takes any binary data and throws it onto the elliptic curve. And you get a random point on the curve. And because that operation is not reversible, it's a hash function. So we call it hash to curve. And the result of that is a point on the curve. This is SecP. This is where Bitcoin lives. We take that point on the curve and now we blind it. And blinding means we add R times G. R is a blinding factor. It's a random private key. It's a blinding factor. We don't share that blinding factor with anyone. And we get this B dash, like B prime. And B prime is a blinded message that we send to the mint. Here's an intricate detail. Y, so this Y variable here, the hash to curve of the secret, is a so-called nums point. It's a nothing up my sleeves point. And the reason why this is important is we can basically prove that if you put something into this hash function, the result of this hash function is a public key, a point, and we can prove that we don't know the private key to that by putting it into this hash function. So basically, there's two kinds of points. Either you retrieve that point using a hash to curve, and then you don't know the private key, or you know the private key and you don't know the pre-image of this hash to curve, right? So this is a point that does not have a private key, at least we don't know it. So we send that the amount that we want and the blinded message to the mint, and then the mint multiplies this with their private key. So it's technically speaking not a signature, it's a MAC, but let's call it a blind signature anyway. So we send that blind signature, this C prime, back to Alice. Alice now subtracts that thing that she added. You know, this is the point where we go back into the visible world. And then we get C, and C is the unblinded signature. Our tuple X, C, and the amount, that's the coin. So that's it. You basically fully understood Cashu's cryptography if you understood this little piece of math. All right, so here's the transaction flow. Once you have this, you can build money with it. So here's how it works. Alice wants to send 1 Bitcoin to Carol. Basically, she takes the coin, sends it to Carol, and then Carol needs to talk to the mint once to prevent double spending. So she sends it to Bob, and Bob sees this token for the very first time. That's the privacy part. And looks in Bob's database and sees that hasn't seen this coin before, puts it into the database. Okay, I haven't seen this coin before, and you get a new coin for the same value back. Now the transaction is complete. This is how almost every eCash transaction works. So I'm almost concluding here. To summarize, here are the most important properties. It's privacy preserving. We have blind signatures. The mint cannot track issuance and redemption. It's a bearer token, so these tokens are the money. You don't point to a chain and say, like, here's the money and that's my key or something. You just have the money and you put it into a message. It's kind of a push UX, so you throw the nut to someone and they catch it. And it's programmable, and I will go into this a little bit more, but we can have spending conditions for these coins as well. So our ultimate goal is not the tech, it's actually improving Bitcoin usage. So we are very interested in just elevating the UX of what Bitcoin can do. And we ultimately want to make it as good or better than fiat, because fiat is really doing great things in terms of UX if you think about it. I know some people will say being rugged is not good UX or money printing is not good UX. I agree, but I think that's kind of way of defining it. So on the left here you see a video of 2 phones, and you tap one phone to another, and then the token that the phone on the right sends to the left, the phone on the left, travels via NFC from one phone to another. And those are 2 different Cashu wallets, and you can receive the coin by just tapping these phones. Because it's a bearer token, you just beep, and the token travels. On the right here, we see a video of new feature of macadamia that is implemented for iOS. Has a special feature that you can use iMessage, the OG messenger for your parents, to send eCash. So you select inside iMessage, you select I want to send eCash, set the amount, and then you drop that token into the message stream. So this is already pretty cool, and this works because these coins are expressed as bearer tokens. So none of this really works, and none of this really makes sense if we don't have Lightning. I think we've been mentioning this like all the time during this conference. Lightning is de facto the common API that we have for Bitcoin subsystems to talk to each other, and it's great. It's working really, really well for that. So here's a typical architecture of what the landscape for Cashu mints looks like. So we have a mint, and they have their users, and the users usually talk to the mint via HTTPS, sometimes via Nostr, sometimes via different protocols. And then they can make eCash payments among themselves, and they can use all sorts of different transports as well. So it could be a text like iMessage, could be NFC, Bluetooth Low Energy, Nostr, anything that can transport data. And if a person here wants to pay into the world, then we use the Lightning infrastructure of the mint for that. If someone wants to pay another person on a different mint, then again, we also use Lightning for that to settle basically from eCash from mint A to Lightning to eCash to mint B. Some users actually have eCash from both mints, so they can even swap eCash directly without going over Lightning. And then we scale this just infinitely horizontally. You can just spin up a new mint, have a Lightning node, and you're part of this network automatically, obviously, because you just support Lightning. And I just checked the mint auditor today, and this is what the list of known mints, at least known to me, looks like, where people have donated eCash from their mint to be able to observe the mint. Here the red dots don't mean that the mint is offline, it just means that one of the transactions recently has failed. So this auditor checks whether the mints are alive and whether their transactions are on Lightning are working. It's a great way to basically observe the mints and see if they are still operational. All right, so this was the eCash part. Now let's get into the more interesting Lightning parts, and I will explain to you some of the ideas that we've been working on that already work, and then some of the ideas that we've been thinking about and do not work yet. So first of all, how do we swap eCash to Lightning, and how do we do it atomically? This is one of the fundamental ideas here that make the other things possible. So first of all, I mentioned the concept of programmable eCash, and specifically in Cashu we have two different script types. We have pay to public key and we have HTLCs. And the HTLCs that we have work basically pretty much the same way as they work in Bitcoin, and because they work the same way, they are interlockable. So we can lock an eCash HTLC to a Bitcoin HTLC. And so an HTLC on eCash, no, Cashu HTLC without Lightning looks like this. So we have Carol. Carol generates a pre-image, it's private, and a hash of it that is public, and this is the hash. And Carol can share this hash with anyone, right? So lock money to this hash. What Alice now does is she takes her normal eCash and she kind of attaches that lock to the eCash. Now that eCash is locked with an HTLC, and then you can send that eCash to Carol. We can do any kind of like a smart contract with that. And eventually, Carol wants to unlock it, and the way we enforce this lock is through the mint. So the mint enforces the script. The mint sees, hey, this is an HTLC, I need a pre-image for that. Carol provides the pre-image, the mint checks that everything is okay, and then the transaction is then complete, right? So now we could take this HTLC eCash and we could take a Bitcoin HTLC with the same pre-image and then put them together and have them atomically swap to each other. So this is what we can do. And before we get there, I should say I need to one step back. So before we get there, I first want to talk about multipath payments and how we've been using them in Cashu so far. So one concept that we've introduced a while ago and now is actually live and working and actually super useful is multi-node payments, which the purpose of which is to reduce the risk of users to put too much money into a single mint. So you can spread your balances across multiple mints, but that creates a big UX issue, which is that now you want to make a large payment, but you have only small amounts on different mints. How do you pay a single large invoice? Previously, you would have to shift the money from all the mints into a single mint and then make a payment, which is cumbersome. Instead, what we can do is we can make one multipath payment from multiple mints. So here's what it looks like in a wallet. So this is implemented. I'm not sure if this is the latest UX, but you enter a normal invoice, and then you go into this multi-screen where you have 3 different mints. And then essentially you choose the distribution of the mints that you want to use. When you press pay, you send the eCash to these individual mints, and they make a multipath payment to the receiver. And in a single payment, which is also atomic, this payment is received by the receiver, and the receiver doesn't even know what's happening. For the receiver, this looks like a normal MPP. It could come from a single CLN node, or it could come from multiple cash mints. They don't know that it's happening, which is great. I also think that this was never intended to happen, but because of the privacy properties of Lightning itself, we can just do this without anyone really noticing that we're doing it. So this works, this is useful, and it's great. So how do we do the reverse? This is something that we're still struggling with in kind of like conceptualizing how it should work. So I call this reverse multinut. How do we receive to multiple mints at the same time in order basically to do a multinut payment afterwards, right? So otherwise the user would have to manually select and cycle through mints and so on. So how would this work? And now this is just conceptual. I think it requires something like an LN proxy. This is an actual project that you might be aware of. It's a kind of a privacy project for Lightning where someone else creates an invoice for you. You share that invoice with the payer, and you create an invoice with the same locking script and give that to that LN proxy. So kind of you share their invoice with the payer, they pay the LN proxy, and the LN proxy pays you. You release the pre-image, and everyone gets their money. This is how LN proxy works for a single path. And I think you can also split this into multiple paths. So I asked the LN proxy, hey, can you create an invoice for 100 sats? And then that LN proxy asks multiple mints to create 33 sats here. And then receives the payment and somehow needs to be able to combine these pre-images. I call it HTLC moon math. Could be AMP, which LND is currently doing. Or with PTLCs, this would just work. With PTLCs, we could just combine these PTLCs and combine it in such a way that it can resolve this one payment. With HTLCs, I think I need to study the moon math a bit. But this is active research, so if you feel like someone who already knows how this works, then just talk to us, please. Another concept, so this is multi-path payments. Another concept is gateways, and this is cool. This is kind of cypherpunk, because so Lightning gateways is something that Fedimint does in its core design. Fedimint is a project where the mint lives on chain, and then Lightning is an additional service hosted by others called gateways. And we want to have the same thing for Cashu, but we want to have it a little bit different. So essentially, what this enables us to do would be to build a mint that does not require Lightning. It would be like a much slimmer operation. You could even have a mint that just has Bitcoin D or not even Bitcoin D basically, but on-chain. And by coupling the eCash HTLCs to the Lightning HTLCs, we can do things atomically so that you don't need to trust the gateways. And this is like a design constraint that I would like to adhere to, is that the mint should not participate. The mint should not know that this is happening, so that we don't need to ask the mint, and the mint cannot even say like they know that this is happening on their system. So this would be ideal. So for outgoing payments, this is trivial, and we have done this, and it's basically simple, as I said before. The goal is I want to give this gateway thing, I want to give the gateway eCash, and I want the gateway to pay my Lightning invoice. And I want the mint to be clueless about this, right? So the way this works is I create an eCash HTLC and an invoice with the same payment hash. That comes from someone else, like my Phoenix wallet created that invoice, and I create eCash with the same locking script, and I give that to the gateway, and the gateway pays it all over Lightning, receives a pre-image, and can get the eCash back. That's how it works, and the mint is just like, what's going on? I don't even know. Everything is good. The mint basically just sees that an HTLC has been settled, but doesn't know why. The incoming way, though, that's the hard part, and I'm not sure if we have a good solution for this yet. But so if you again have an idea, then talk to us. So here's how it would work already. So this is the way it should. Sorry, this is the way it should work. So I want the gateway to receive something on Lightning, give me eCash for that, and I want to be asleep while doing that. So I want to log off and chill on a beach while this is happening, and I want the mint to not know what the hell happened here. So here's one way of doing it without going to sleep. So basically it means I ask the gateway, I give the gateway a payment hash, similar to an HODL invoice, right? I tell the gateway, create an invoice with this payment hash. The gateway gives me that invoice. I give that invoice to my friend. My friend pays it to the gateway, and the gateway gives me an HTLC, eCash HTLC. And when I spend the eCash HTLC, so when I receive the eCash HTLC, the gateway basically gets the pre-image automatically. So the gateway can subscribe to the mint for updates for this coin, and then get the pre-image and then release the payment on the Lightning side, and everyone is happy. So the gateway got the money, I got my eCash, no one can rug anyone. Problem, Alice needs to be online. That's the part where Alice would like to go to sleep. But Alice needs to be online. So this is, you create a payment and then you need to keep your wallet open, which is not ideal UX, I would say. So how could we do this? Maybe with, and also enable Alice to go offline. And this is not a solution yet, but maybe an idea towards the correct direction. And it's also inspired of how Fedimint does it, but again with the asterisk that we don't want the mint to participate in it, so it makes it a bit harder. So I introduced a new actor called the pre-image dealer. And basically, we do the same thing. We ask the gateway to create a HODL invoice, and we deposit the pre-image with the pre-image dealer, and then we go to sleep. So now we can log off. And now when the payment arrives with that gateway, the gateway pings the pre-image dealer and says, here's an HTLC, eCash HTLC, so keep this for the guy who, for this guy. And the pre-image dealer then releases the pre-image to the gateway. Now the pre-image dealer has the money, but then the pre-image dealer suddenly can steal the coin from the user because the pre-image dealer now can unlock this. So that's the problem that we haven't been able to fully solve yet. I think it should be able, it should be possible somehow by also requiring another spending condition on the coin. So again, this is also something still in research. So if you have any ideas, please approach me about this as well. In summary, I want to illustrate the security model that we operate with. So these three are the user, the gateway, and the pre-image dealer, and they all hold up guns against their heads. We don't want them to have to trust each other. So any solution should be in a way that these three guys cannot rug each other. But obviously, there's always the mint who all of these three guys have to trust. So the reason why these three guys don't need to trust each other is because they trust the mint. And that's kind of the design framework that we work with. And in the best case, the mint doesn't know what's happening, right? So this would be the ideal way of building these systems. And with that, I'm basically at the end of my talk. One last motto shout out there is that we just love magic internet money, and that's why we love Bitcoin. And hopefully you enjoyed this talk. And if you want to support Cashu, you can support us via OpenCash, our nonprofit that cares about our developers. And with that, thank you.
Any questions? Perfectly succinct, it
Zero
seems.
questions.
No.
There's one.
Do you have some cool ideas on how to handle fees when accepting eCash versus, for example, from different mints where you then have to redeem them? And it kind of changes the dynamics in Lightning where usually the sender pays the fees, but in eCash, kind of the recipient pays the fees. Maybe that's okay. Maybe that's okay. Maybe you have some cool ideas on how to change that or fix that or keep that.
Yeah, that's a good point. And with eCash, it's a bit more similar to on-chain, where so in order to receive the coin, you need to pay fees. What you can do is that the sender adds those fees to the payment itself, because the sender can predict the fees. It is a bit similar to how it works with on-chain because it depends on the UTXO distribution, and in this case also on the eCash distribution. So the more coins you have, the higher the fee will be for a transaction. So it makes sense to consolidate your coins and add some fee on top of that. That all is eCash fees. This is something that a mint can just enable. A mint can basically say, I want a slim part of each transaction if someone deposits eCash, because the cost is carried by the mint by keeping those eCash nodes in the database forever. So every transaction causes a little bit, adds a little bit of data into the mint's database, which is why there is a fee model attached to it. I don't know how you would be able to optimize that, but adding the fee to the transaction so far has worked quite okay.
Thank you very much. Let's hear it for Calle.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. their walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Accompanied by the blue mat from Spiral, Christian Decker from Blockstream, Nicholas Goline, OpenSats. And it looks like we're missing one.
I don't know where Fabrice is.
Fabrice from Async.
Cool. All right. I don't know where Fabrice is. I know he had to catch a flight, so maybe he wasn't able to stick around. Hey everyone, how's Lightning Plus Plus going? Good? Feels electric in here, don't you think? Yeah, okay. Great, so I'm here with a panel of some really accomplished developers that have been in Lightning space for a long time. Thank you, Christian Decker, Matt Crowell, and Nicholas for joining us. A lot of the people in the space, I think, are building projects on top of Lightning, but Lightning wouldn't exist without the spec and all of the implementations and all the developers working on building Lightning. So very excited to sit down with pretty much core developers that have been working on the spec process for how many years now. So without further ado, we're going to go ahead and get started. If I could get you guys to talk about maybe when you started on Lightning, what implementation you work on, and what version of Lightning you're currently implementing.
Well, me and microphones, that never works. So I'm Chris again. I don't know if I can count my PhD time as working on Lightning, but if not, it's 2015 that I started working on off-chain protocols pretty much. And ever since joining Blockstream, I've been working on this, so it's like 9.5 years now. Switching focus every once in a while, but the most fascinating aspect of all of this is essentially the collaboration that we have among all the teams and sort of the very nice and technical discussions that we have in the specification. And I'm actually really proud about what we built here with Lightning. And it hasn't always been a straight line, but we got there in the end, I guess.
Taking a circuitous route, perhaps, one could say. No, sorry.
Me and circuits.
Matt, what got you into Lightning? So you started in the Lightning protocol the same time I did. I feel like my spec meeting was your first spec meeting.
I was trying to look up when first Lightning started. I don't know.
Like 2018.
Probably.
November 2018 was the Adelaide spec meeting. I think you were new to Lightning then.
So it must have been 2017, early 2018 or something.
Yeah, so you work on Rust Lightning. Maybe that's a good thing. Or you started Rust Lightning, really.
Yeah.
Okay, and you started in 2017. You were working on Bitcoin Core before that. Why did you start working on Lightning?
Bitcoin Core got boring. I mean, but it did. Bitcoin Core struggled a little bit after the block size wars to keep making progress. A lot of people kind of went off and did other things after the stress of the block size wars, often in Bitcoin, but went off and did other things. It kind of stalled a little bit. Luckily, it's much healthier as a project these days. But I was looking around, kind of looking at where I could have an impact on Bitcoin. Wanted to learn more about Lightning. Wanted to learn Rust stuff, so started just hacking around on it. I made some good progress. Had like this cool little toy implementation basically at that point, and then we started Spiral, then Square Crypto, and we hired a bunch of people. We had kind of a mandate of like make a large impact on Bitcoin. We had a team of full-time people, have an impact that was more than some of these other dev shops that just have kind of wandering, meandering developers doing their own thing on their own, but rather having a larger impact that can only come from having a team of people working on the same project. And we kind of looked around at the same time and kind of said like, okay, well, maybe we have an impact on privacy, maybe we do some privacy stuff, maybe we do some wallet technology, like where's the impact we can have? And we kind of concluded bringing Lightning to more self-custodial models and making Lightning more of a built-in default for Bitcoiners was by far the biggest impact we could have. And so we kind of adopted the Rest Lightning project, turned it into the greater LDK umbrella, which now has other stuff under it. And yeah, that's been 7 years now that we've been doing that.
Cool. How big is the team now?
Including non-developers, we're 15. I think we're 7 engineers on LDK, plus some engineers doing non-LDK stuff, plus some non-engineers.
Cool. Nicholas, what's your story with Lightning?
Well, I was just a user trying to understand what Lightning was. I've been in Bitcoin since the early days, since 2009. And then, like, as a user, not as a developer, I was doing a lot of enterprise stuff. Open source was not crossing my mind back then. And then I started using Lightning back in 2018. And it was very hard. And there was no support. The documentation was very bad on the implementation side, not Spec, but how to use it, how to do it. It was a lot of talking to people that were already doing, running their nodes. And then I ran a node for the first time, didn't know what HLC was, and then I just got wrecked. I got a lot of forced closes, and I stopped doing Lightning altogether. And then I worked at a company, a Lightning company, Zebedee. And then I got a little contact with Lightning again, but not as a Lightning developer, more like backend developer, like the enterprise business side of stuff. And I like it, what I saw there. So when I decided to stop doing enterprise jobs and moving to open source, it made sense to start implementation from the ground up, because I wanted to learn about Lightning, like the real Lightning on the Spec, like the transactions and everything. And it made sense to create my own implementation. So that was the hook for me.
And you started that when?
18 months ago was March 2024. And after 160,000 lines of code, I can open a channel against all implementations.
Very cool. And that you just did that today, right? Like open
Yeah.
first. Is that the first time you've done that?
First time doing a public demo. I
cool.
did this demo like a couple weeks ago in BitDev São Paulo, so this is the second time.
Cool. Very cool.
Thank you.
And you, how big is your team? currently?
Me. It's just me coding. And I guess even though it's just me coding, I see that I'm doing a little different from you guys when you started. So it's already established, Lightning. So my take is I have to pursue like the big guns, the fiat market makers. So fiat banks and everyone else. Because if we want Bitcoin and Lightning to thrive, we need them on our side. Like, because else it's just a bunch of nerds running nodes and moving money around. Like if we want like everyone else to use, we need them to use as well. So I'm seeing myself as a Trojan horse. So hey, it's .NET. You are familiar with this. So what about using this? You already have devs. Let's try Lightning and Bitcoin, and maybe we have this adoption.
Right, and so your implementation is different in that it's in C#, which is a .NET Microsoft project.
Yeah, because not every single bank, there's a few banks that do Java, but most banks and insurance companies, airliners, they all use .NET on the back end. So it makes sense.
Cool, yeah, it makes sense. Well, Fabrice, you work at Async, I say that correctly?
Async in French, async in English.
Okay, async. And how many? So you've been working in Lightning since when? Yeah, maybe tell us your story about getting into Lightning, if that's cool.
Right. So we founded Async in 2014, and we started to work on hardware wallets. And I think at the time there were two of us. We're probably the first people in the world to implement most of the Bitcoin protocol on smart cards. Java card and Multos, and we wanted to build a hardware wallet. And it didn't work because we knew nothing about electronics, about manufacturing, and that's a real problem. It's not the technical side of things. So in 2015, we read the Lightning paper, the white paper, and we found it really interesting. And a few months later, Rusty Russell published a series of blog posts. Basically, the Lightning white paper is cool. There are things that are missing to implement it. We should do it. That's what his blog post. And we thought, yes, we know about software development. We know about distributed systems. This is probably something we could do. And we started, I think we were the second implementation just after C-Lightning at the time, before the specs. And we've never stopped. And the goal for us was to be part of that payment infrastructure that is built with Lightning. So from the start, we knew we wanted to be one of the operators of the Lightning Network, a big one if possible. And that's what has been driving everything we do. Everything we do is focused on how does it impact our Lightning node.
So you guys are running, you guys had the biggest Lightning node. Do you guys still have the biggest Lightning node in Lightning?
I don't know, because the public capacity is not the real capacity. We have a lot of private channels, but it's probably in the top 3 today.
Top 3. That's cool. But you guys had the biggest one for a long time, like in the top 3 since the beginning of the network, right? So when you're talking about the specs and stuff, maybe we should talk more about like each implementation and kind of what makes each one different, or like what the kind of the motivation is. So it sounds like your implementation is because you want to run a node.
Yes.
You guys want to be operators. But what were some of the like maybe aspects of the spec development process or something that maybe you think is downstream of being such a big operator of Lightning as well?
Our main concerns are security, but I think it's not really related to Lightning. It's mostly the stuff I described yesterday about the nightmares we had when we were running on like standard servers that we solved partly with secure runtimes. The other thing we looked at very early is mobile wallets. It's an experiment for us. Phoenix is an experiment, not in the sense that it doesn't work properly, but in the sense that we're trying to push what can be done in a non-considered way with Lightning. And this is a part of the spec that I think was not really looked at properly for a very long time. The gossip sync was awful. It is still awful now. It's a mess, but it was really bad. That's something we try to improve, and also everything that makes running a node on mobile phones easier is something we really look at. Like, we love dual funding, we love splicing. In the presentation, someone said that you used to have 50, 60, up to, I think someone had more than 100 channels on their mobile phone, which was a mess. With splices, it's just one. It's an amazing feature. And we hope that we can get everyone to implement dual funding, splices, and equality ads. Please lobby your favorite implementation to do that, because that makes Lightning much better.
Cool, very cool. Yeah, and so you guys, so you guys have 2 implementations of Lightning, right?
Yes.
Can you say more about that? So I think everyone else here is working on a single implementation, right? Am I right about that? Okay. So each of us, Christian, we didn't hear much about core Lightning you work on. We should probably come back to that. But you guys are building like a single implementation. You guys have two.
Yes.
Why do you have two?
Eclair is tuned for really large nodes, lots of volumes, no downtime. We have really good uptime. We use Postgres, which is not necessarily a good fit for everyone. We use the JVM, which is a runtime that is, I think, badly misunderstood. It's probably one of the best runtimes for these type of things on large servers, but maybe not on really tiny machines. And we wanted something that was native to mobile development. And there's something that is called Kotlin multi-platform. I don't know if people have heard of it. It's 4 or 5 years old, and it's really amazing because the same code is compiled to natively to work on Android, on iOS. So Phoenix, probably 90% of the code is a single code base, which is in Kotlin. And since it doesn't route payments, it's much simpler than Eclair. So that's why we have a second implementation. It's basically Eclair ported to Kotlin, and you remove everything that is linked to relaying payments.
And so the Async one, sorry, I got it. The Eclair, wait, there's two. What's the big one?
Eclair is the big one
Big
in
one.
Scala for
And it's
like
in
big
Scala,
nodes.
which
Yeah.
compiles to the Java virtual machine.
Yeah.
Which is kind of interesting because Nicholas is working on C#, which is kind of like the other enterprise Lightning project. And then you have one that is in Kotlin,
Yes.
which compiles to be run on the phones, and that's Phoenix.
Yes.
Cool. Okay. Very cool. How many people here use like a Lightning wallet? Almost everyone. And how many of them is it Phoenix? Like, okay, so like about 50% are like Phoenix users. Very cool. Cool. Okay, Christian, I guess like, so we didn't talk much about core Lightning. So it sounds like the Async team is working on, you have one big node and you also have a mobile application, and that's kind of the two, and you run your business around that basically. Christian, what is the Blockstream's core Lightning implementation kind of like, how is it structured? We only have one. How is it maybe different than like an enterprise and a phone app?
So essentially, when I joined, Rusty had already been working on C-Lightning for a year, and Rusty, being a Linux kernel dev, knew C best. But he also had quite a lot of experience when it came to specifications and how important a standard document is that is authoritative. Well, we couldn't have that authoritative spec for Bitcoin itself. Trust me, I tried in 2011. It did not work. His main intention for core Lightning was actually to be an experimentation platform for to test out specification proposals, and that went really well with what I mentioned in my talk. Was essentially the Unix philosophy, having many small components that are simple in themselves, but the complexity arises through their combination. So this sort of this orchestration of various parts lends itself really well to sort of swapping out individual parts, trying out something different, right? Maybe trying out a new transport protocol, maybe trying out some new HTLC construction, while the core is still all together. He called it C-Lightning because it was written in C. That ended up no longer being as true as we brought in more and more diverse languages. Some parts are now written in Rust. The plugins can actually be written in any language you want. And the goal here was to essentially open up the Lightning node for experimentation, customization, and tailor it to your own needs as you want. And so I think the breadth of applications that we can serve with core Lightning is quite impressive. And the sort of slicing of the node into various parts has proven very nice for us to essentially just customize it to whatever scenario we need. It may not be as portable as LDK, which essentially you can compile for every single platform there is on this world, but it's a bit more coarse-grained than an API would be. But I think we made a relatively good choice in where we put these interfaces, such that you can swap out, even without coding experience, you can go and make it your own and actually adapt it to your own needs. this specification first approach was essentially born out of the need of yes, we want multiple implementations. Unlike in Bitcoin, where any deviation from a standard may cause a hard fork, all of a sudden in these layer 2 protocols, we have this ability of quickly experimenting, trying out new stuff, discarding ideas even, right? Something that in Bitcoin you could not do. You introduce a soft fork, that is forever. Whereas in Lightning, you can just try out something new. You can be very agile when it comes to protocol development. And the C-Lightning and now Core Lightning implementation tries to make that apparent and give you the tools to do so. And we have a variety of projects that are making use of that. And I think they have very, very interesting trade-offs due to that.
And you also work on Greenlight, right? So Core Lightning is like the reference implementation in C of Lightning Spec, as at least how Rusty explained it to me forever ago. And then there's also maybe one of the ways that you're using module stuff is you have Greenlight implementation. Is that a separate implementation, or how do you think of like, well, what is Greenlight? And then is it like an implementation, or like how would you think of that in terms of like what has been built with Core Lightning at Blockstream?
So Core Lightning is certainly a building block that is very, very important for Greenlight. Greenlight, if I had to put it in one sentence, is essentially a Lightning node as a service. And we try to make it as flexible as possible while assuming the least possible amount of responsibility. So you essentially keep full exclusive control of your funds. We never touch them, which allows us to sleep very well. And it turns out, yeah, the sort of interfaces we chose back then actually match really well the sort of control that we would like to express in this system. So the one example that I always bring up is we actually just move the signer under control of the user rather than the node operator, and all of a sudden you have a system that can be operated by an untrusted party or a semi-trusted party. So yeah, Core Lightning is a foundational piece and is also the enabling piece for us to later on allow you to take on ownership of your node. Because I like to think of Greenlight as sort of the training wheels on your bike, and eventually you want to take them off and ride the lightning into the sunset, right?
That makes sense. So it started as Core Lightning, which is a reference implementation, and now at Blockstream they're building kind of the Lightning as infrastructure, lets you hold your own keys, bit run Lightning without having to worry about having access to the server, etc. I like to kind of compare that to the project at Matt Corallo, the LDK. So when you started LDK, it was very different than every other Lightning implementation. Can you maybe explain like why and what made it different?
Yeah, I mean, when we started, so by the time Rust Lightning even got started, let alone when Spiral kind of adopted LDK and started productionizing it, there was already LND, there was already Core Lightning, there was already Eclair. These freestanding daemons already existed, and the Rust Lightning project already was very flexible, and so we wanted to double down on that and say, okay, can we, one of our top line goals was really, can we take Lightning and make it the default in Bitcoin wallets? I still really believe that would be a good outcome for Bitcoin. Obviously, that hasn't really happened. Lightning still is the only real trustless layer 2 that exists. There's various other things that have come out more recently and some things that people are using. And with Covenants, Arc, and these other things can get to trustlessness, but they're not there yet. And so I still think that it would be nice if Lightning were a default in more wallets. But we had this thing that was super flexible. So we had this Rust Lightning thing. You can stub out how you do disk, how you do network, how you do whatever, and run it in any platform you want. So the classic example of this is Mutiny. They were able to take LDK and put it inside of a web browser, inside a progressive web app on mobile, and make Lightning work entirely in a browser. And that's because our networking didn't assume that you had TCP sockets. It just let you stub out however you want to do networking, which is kind of nuts, but it turned out to be really cool there. Obviously, we haven't really succeeded at getting Lightning in every mobile wallet or in every Bitcoin wallet. Instead, we've accidentally had a lot of success on servers and in big enterprise environments. We've kind of become the default for if you are a large enough enterprise that you have developers who are going to invest the time to actually build a ton of software around your node. You're not a startup, you're really a larger enterprise. We've become that default. You know, we have bindings in a number of languages, so we support Java or Kotlin that Cash App and others use to build their LDK-based nodes. We have C# bindings, we have JavaScript and various other bindings. And so like Lightspark uses LDK for their Lightning node integration that they sell to large enterprises. So like Coinbase, we power the Coinbase node. We power Cash App, so we power a fairly large portion of the payment sends and receives on the network, despite not having very many large nodes. There's the block node, but that's kind of the only large LDK-based node. And we do still have some mobile stuff. We have a number of things that are where people want really lightweight nodes, so like AlbiHub, stuff like that, where you can take LDK, strip it down, run a super lightweight node, and then stub out some of the logic to not have to have a ton of overhead. So yeah, I mean, we've ended up with something that's fairly flexible. I mean, it scales from kind of the block node, one of the larger routing nodes on the network, all the way down to, you know, AlbiHub individual size nodes. And works great on mobile, although there's not very many mobile clients today. Turns out Lightning is really hard. You can see my talk, but you know, I think we have a really good product for it now. It just took a while to get here. There's a lot of challenges, like Fabrice mentioned, to get there on mobile. But yeah, I mean, we have thus far largely avoided having a daemon. It's always been a library. You know, a few years ago we introduced the LDK node project, which is not, in fact, a freestanding node. It is still a library, but it reduced the amount of code to, you know, like 10 lines of code to actually spawn your own Lightning node, and then you can tightly integrate it however you want. It still did all the work for you. It's just not a freestanding node. We have a demo freestanding node. We might start actually investing in it a little bit and have a real fleshed out RPC interface on it. But we've found a lot of success with like anyone who wants to do anything that's not just take a node and run it. It's kind of been LDK is the only real option. And so there have been, as Lightning has matured, as more large enterprises have gotten involved, you know, as people have wanted to test weird ideas like running Lightning in a browser, hopefully more so in the future, running Lightning on mobile phones. It's been something that people have reached for because it's the only option. And Lightning is a complicated protocol, not just in terms of the amount of complexity in the protocol itself, but then on top of that, we wanted to have this super flexible API that's super full-featured, and that also adds complexity and also adds more effort. And then on top of that, there's just always constantly new protocol features in Lightning, so splicing, Bolt 12, onion messages, all these things that take a lot of resources to keep up with, let alone, you know, do maintenance and backlog issues and fix bugs and whatever else. So Lightning has become something where you need a rather large team to have a competitive implementation and really add value to the ecosystem. But luckily, we've been able to do that with Block's generous funding of us. And then also, we've continued to grow the LDK contributor base, and we now have a number of contributors from outside organizations, which is really nice.
And just like, I think one thing that you hit on, but just maybe because it wasn't super clear, is you can't go download LDK and run it, like sit play like you would maybe.
Yeah,
like
it's not a daemon. There is LDK server. There's a GitHub repo for it.
Okay.
It barely has an RPC interface. We intend to actually finish the RPC interface at some point, probably soon, but
2 weeks.
Yeah, I mean, it's just not historically been a priority for us. I think increasingly looking forward, it might be just because we want to have more built-in LSP support for people, so that people who want to run an LSP to service things like AlbiHub and those users or you know, other mobile wallets, people can more easily run LSPs, because sadly that's something that doesn't exist out of the box anywhere. So that might be something we build just for people to have. But yeah, historically LDK has found success despite not being something you can download and run. It just serviced completely, totally different use cases. which has turned out to be really important for people to grow and for the Lightning Network to grow, for people like Cash App to adopt it and run it in their super bespoke corporate infrastructure that has all kinds of weird rules that you can't just take a daemon and run it. I mean, you kind of can, but not really.
Cool. I want to get back to this idea about like what people are working on in Lightning, but I'm curious, Nicholas. Like we have a bunch of different nodes or Lightning projects. Your project is still in the development phase. Do you have an idea about what NLightning is going to be? Is it going to be a library? Is it going to be a full-fledged node? Is it going to be like a mobile-focused project?
Well, it's interesting that each one of us have a different end game for this, right? NLightning is a library and will be a full node. So it's both. As a library, it's being used in production already. Boat 11 is used by Zebedee. Even though there are bindings on LDK bindings for C#, for a C# developer, using something that they can add to like they can find a bug and just create an issue and a PR on top of it. It's a little easier if it's a tech-savvy dev than using another language. So that they decided to use it since day one. Like it was my first package, and it was being used from the get-go. So it's a library. If someone wants to build on top of it, they would be able to. But I want to have a full node as well. So you just download it and run it. But at the end of the day, don't get me wrong, I would love to have like everyone in this room running an Lightning node. I guess I'm pointing more to this very specific niche use case, like not enterprise businesses on the Bitcoin ecosystem, like enterprise outside of Bitcoin ecosystem. So I really, really believe that we have to get those guys to use it so we can grow more. So I'm pointing towards that direction. So it's going to be like, you want to run it, you can download and run it. It's free open source software. You want help setting it up? Okay, I can help you. Like I will sell support for this. You want me to run all of this? Okay, I can hire people, train people, and now you have all this infrastructure built for you running inside of your organization. So I'm thinking about this level of support. So it's basically about support, what I'm doing. So what we don't find in Bitcoin and Lightning, or actually on open source software, it's like that's it. You can use it. It's free. So since it's free, you're not paying me anything. I will solve bugs when I can. And for me, working my whole career, 16 years, for banks and credit card acquirers, insurance companies, and all of that, I can see they need this, what I'm offering, want to offer once I have the full implementation, which is not far. So right now I'm missing 2 boats, boat 4, which is Onion, and boat 7, which is Gossip. Probably the most difficult ones ahead of me. And then after this, it's a full node. So you can run it.
So you have 12?
Not yet, because 12 was merged when I was still like starting the idea. So I want to have like the 10 boats, because we skip at 6.
Yeah, I was just about to ask, did you implement Bolt 6?
No. So we skip at 6, so I want to implement the 10 base boats, and then after I finish this, then I can implement boat 12, and then probably I will get some help, not being alone anymore, and then we can do splicing as well, and like help. I want to help more on the spec side of things. I've been mostly a listener on the spec meetings, because I cannot bring much, because I'm building all of this, standing on the shoulder of giants. You did all the work, you spec it out, everything. You have done what we see on Lightning. It's because of you guys. So I'm getting late to the party, so I cannot bring much. But I hope to bring more. Like my implementation, I already have like a list, as soon as I have something working, like this demo was very important to me, because now that people can run it, like you guys can, if I say I have a bug against your implementations, like it's not like strictly according to the spec on this point, you can just download my code base, run it, and see for yourself, oh yeah, this is different. So I was waiting until the demo, so I can bring more to the table as well. So I have caught like some strange behaviors, like the ping pong. On the spec, it says it has to be random, and you can send random bytes up to the size of the message, so short. And then you can ask for bytes, but most implementations, they do it every 5 minutes, and they send 32 bytes and ask for 32 bytes. And then when I ask for 34,000 bytes, because it's in the spec, it just breaks, because they cannot send this. So I'm finding things that now, with a working daemon, you guys can test against. So before it, you cannot test against. It's just me saying. So now I can get more hands-on on the spec as well and bring more things that I'm finding.
Absolutely, yeah. I think one of the, it's a very important contribution to do a spec-based implementation now that the spec has sort of settled, because I mean, all other implementations have seen it grow, and we've gotten accustomed to all its nits and all its warts, and there is just stuff that we are blind to because we've approached it from a certain point of view, despite all of us coming from different applications, right? Mobile and big routing node, experimental platform / we don't know what to do, so we leave customization open to we know even less what to do, and we ask people to come up with their own parameters. Essentially coming in late, in this case, is something that will help us see where our blind spots are and eliminate them and make sure that the specification is flexible enough and covers all of the use cases that we, coming from different backgrounds, are actually looking for. That is something that, if I may bash some Web3 stuff right now, being in the Web3 hub, that is something that I've not seen other projects do, right? They just invent a standard out of thin air. There is no collaboration, and then they sort of pin themselves onto one very specific use case. The Lightning specification might not be perfect for any specific use case, but it is flexible enough to be this glue code that glues together various applications and various use cases into one protocol that is cohesive and that ultimately creates more value than any single small network. And that's also why I decided to abandon my own research ultimately and join the Lightning train, because together we can make a better network that brings more value than two distinct networks. So I do not regret joining Lightning, and I'm really proud of what we've achieved here.
Yeah, totally. Yeah, and like I did originally implement it from the spec, and indeed we found some stuff, but that was so long ago. It's time for someone to do it again. Really quick, you said some implementations ping every 5 minutes? That's insane. That's buggy as hell. No one should be waiting that long.
Yeah.
Who does that?
Well.
All right, well, tell us afterwards, because that's really buggy. People need to be pinging more often. That's really broken.
Yeah, like on the spec, it says between 30 seconds and 5 minutes.
Yeah, I don't care what the spec says. It should be 10 seconds.
Well,
that's wrong. We should fix the spec, and then implementation should fix their shit.
That's a good
buggy.
point. That's a good point. Like, I've heard when I met you guys before on the summit, and I heard something very cool from Russi. He said, "I'm eager to know what we'll find, because we don't have a new set of eyes on the spec for half a decade, so it will be good." So I'm already finding some specific stuff from implementations. And then now I can bring it up on the spec meeting, like, oh, we should either change the spec or you guys have to conform to it, because I'm doing it as the spec says.
Do we have a meeting tomorrow? Do we have a meeting tomorrow? Is it tomorrow or
tomorrow
next Monday?
Sunday.
Oh, it's after
Today's
the
Sunday.
day after
Oh wait,
tomorrow,
no, day
right?
after tomorrow. Just the day after tomorrow. All right, well,
guess
somebody
so.
remember the
Time
5
zones.
minutes. All right, time zones are hard. Somebody remember the 5 minute thing, because that's broken. We need to talk about that on Monday.
Cool. So we have about 7 more minutes on the panel. There's so much more that I want to ask you guys, so I'm going to try and get in. I think we've talked a lot about history, what's different about your implementations, kind of what market we're going for, but we haven't actually touched much about like what's actually in Lightning and Spec and like, you know, I'd love to hear from you guys. Like, you know, there's a lot of stuff that we've proposed and talked about adding to Lightning. What's like maybe one feature that we've talked about or that it's on your roadmap that you're excited about adding to the Spec?
I mean, Gossip v2, when LND finally finishes the Taproot-based Gossip, but it's not the Taproot-based Gossip. We don't care about that. We care about Gossip v2, because then after we get to Gossip v2, we can do set reconciliation-based Gossip. And I think JHB gave a talk about mini-sketch-based Gossip yesterday, I think. Sadly, I missed it, but I will catch the YouTube video wherever JHB is. I'm sorry. But the Gossip in Lightning is horrendously broken. I think it got mentioned earlier. It's slow, but it also is just buggy. Like, Gossip is not reliable. I think anyone who has a Lightning node that only has a few peers probably has seen at some point Gossip just randomly doesn't work sometimes. It doesn't make it through. Some nodes rate limit. Some nodes are buggy. Some nodes drop, whatever. We need to fix Gossip, and given how broken it is, probably the easiest way to fix it is to just tear it up and rewrite it, which basically Gossip v2 will let us do. Mostly because we can change the Gossip messages to, instead of being time-based, they can be block height-based. You can only update your fee rates once every block. I mean, you can burst it a little bit, but you're only going to be allowed to update your fee rates once a block. And then once we have that, we can use mini-sketch, and that will let us finally fix Gossip and not be buggy as fuck.
Please do this before I implement Gossip. I want you to do it all once.
Ooh, the pressure is on now.
Yeah,
the Lightning Labs.
I already implemented channel v1 because on the summit, Rusty said, oh, skip v1, go straight to v2, so I implemented v2. On the first test, no one talks v2, so I got back and implemented v1. Now I can open channels, so I don't want to do it again.
Yeah. Rubies, what are you guys excited about in terms of forward-looking Spec stuff at
having proper zero-fee commitment transactions. That would be a huge, huge improvement. I don't know if everyone is aware of the problem, but the commitment transactions are supposed to be valid, which means they should pay fees. Fees change all the time. So for a long time, we had this horrible update fee message, which means this is what I want you to create. This is what the fees I want in my commitment transaction that you send to your peer. It changes when the fees change. It's a huge mess. It makes understanding the balance in your transaction hard, because where did the fee come from? So getting rid of that properly and having the ability to bring your own fees with package relay would be a huge improvement.
Cool. So getting rid of dynamic fee updates.
Yeah.
And that required changing, that's like V3, built on transactions V3, so it took a while to get that into core.
Yeah.
For once we beat you, we have it.
Cool. Christian, what do you got?
Since we already have like 2 short-term updates, and by short-term I mean 1 or 2 years, let me aim a bit higher and go for multi-party channels. Because with multi-party channels, we can actually eliminate all of the risks that are involved when it comes to backing up channels. It's a much, much safer environment to work with. You essentially can now have many more people inside of a single channel. The funds you allocate into a channel can be freely moved between all of the participants, meaning that you have much more expressiveness, and the use of the funds that are in those channels are much more flexible. And that's not just my feeling, but I think René had an excellent presentation yesterday, I think, on how this additional expressivity can make funds in channels give more utility to users. So I would like to eventually see a less toxic waste-producing implementation of off-chain protocols. Whether that's one we already know about or one that will be invented in the future, I don't know. But I think that would be my North Star right now.
Yeah, I second that. Like, my take is multi-party channels. But then we depend a lot on on-chain, on how to do it. And then I'm all about let's just have all opcodes that people can come up with. Let's break it. And then we can have like, not all, but I mean, we need to change some stuff on chain before we can have nicer stuff on Lightning. So, and I don't see this happening anytime soon, like 10 years, maybe.
Yeah, that's pretty much why I'm saying it's a very long-term thing.
I would love to see multi-party. It would change the topology of the network so much. It would make like Lightning really usable. Yeah, like right now it's really messy. Like I have a node running. I used to have 2, now I have just 1. And then I have like, I don't know, 10 million sats there. And then I'm unable to pay more than 5,000 sats, 500,000 sats in a transaction because I'm not that well established yet. I don't have so good connections. And if I had like a multi-party channel, I would be able to route this differently, and the topology would change a lot. So
what's missing for multi-party channels, just so the audience has a better understanding?
There's many combinations that would enable it. I mean, SIG no input is one of them. CTV plus checksig from SEC is another one. TX hash plus checksig from SEC is one.
Yeah.
And then about 5 years of work on the Lightning implementations to get there.
But basically we need to add a new, something needs to be added in the opcode or scripting at the base layer in Bitcoin Core. So we need basically that's a soft fork that we're talking about, right? Okay.
And to be fair, I think there is movement. It's sort of thawing slowly. For a long time, we sort of tried to make very, very small proposals that would only enable our own use case. And I think we're getting back the chance of having a pure engineering-led discussion of what do we actually want to achieve, what do we actually want to enable on Bitcoin, and once we have set those goalposts, let's have the open discussion of how to most efficiently achieve that. And that might be throwing away everything we've done so far, but I see us moving there eventually. Now that all of the FUD and crying and shouting has moved over to op return, we can finally move on all other stuff.
I hadn't thought about that. That's a nice silver lining. Yeah.
Thank you.
Cool. Any last thoughts before we wrap up? Maybe where people can find your project, what's a good way to contribute or run like in your particular thing, and then we'll take maybe a 2-3 minute break and come back for the final hackathon, I think, awards and wrap up. So yeah, Nicholas, do you want to start?
Yeah, for me, it's hard to get funded. I'm an OpenSats grantee for the second year, and it was a hassle. The first time was a hassle, and the second time was even worse. Like the first time I decided to be an open source dev. This is my problem. I had limited money to burn to show like a proof of code. So I burned that money. And on the last like 5 days, I got the grant. Like with a lot of help from friends that spoke to other friends, and then I got the grant. And this year was even worse. So I already have hundreds of thousands of lines of code. There's a proof of work. And even though it was very hard, like some people find that this is just a pet project or something, and some people don't believe it's worth it to have a new implementation. And forget about language, like what we said last. Like, it's important to have a new set of eyes on the spec, and even if NLightning doesn't go anywhere, it's one dev, it's extremely cheap for like people that run the business of developers, you know, having grants and everything. It's extremely cheap for the outcome. Like Lucas from Vintium, he has a nice saying about me that is like, even if there's not a single user, you will be a great asset for the developer community, because there's like 10, 20 people that crossed the spec and implemented Lightning. You will be like 21, you know? So it's another one. So this for itself, it's a lot. So I hope people take me serious, I guess. And I hope next year it will be easier. So if you find what I'm doing interesting, reach out. Every single set counts. For someone like I'm already 40, and I decided to change to open source at 40 with a kid. So, well, it's not cheap to live. Thank you.
Yeah, I don't know how to follow that. lightningdevkit.org. Check us out. Come talk to us. We tend to be pretty hands-on with anyone who has novel use cases of Lightning and wants to build on Lightning Dev Kit. So we tend to be as hands-on as you want us to be with your project. Come join our Discord. Ask us questions. Yeah.
Yeah. So my ask would be that please run our stuff, all of our implementations. Try out new stuff. Tell us about it, the good, the bad, the ugly. We essentially can only work based on your feedback. So bring it on and we'll fix it.
My wish would be for everyone to not completely give up on non-custodial Bitcoin and Lightning. There's a lot of friction. There are things that are really hard to do, like, for example, what does it mean to own Bitcoin? It's not a trick question. What do you think it means? For most people, it means you own a UTXO. So what does it mean to own 5 Satoshis in Bitcoin? You can't have a 5 Satoshi UTXO. So you need to find a way to implement this. And there's going to be a compromise. And it's something we're all fighting with. There are probably better solutions than using Bitcoin UTXOs, but they're less private, they're less safe. We should really try not to give up on what we're trying to achieve, which is sensorless, trustless payments using Bitcoin. Even though sometimes there will be friction.
Cool. Thank you very much, guys.
Are you just trying to shill my talk, Fabrice? Are you just trying to shill my talk? Is that what you're trying to do here?
Cool. Thank you, guys. We'll be right back, guys, after we reset the stage.
To me, it's like Nicholas was preaching about sovereignty, and of course, Sovereignty Edition is the very next one of Bitcoin++ in Taipei in December. We'll see you there. Let's hear it for the panel again one more time. Thank you.
The city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. The city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Finally come, unfortunately, that we have to start wrapping up this fine Bitcoin conference. Hey, you lot over here, come on. Shh. Come sit down. It's the closing ceremony and there's prizes being given out. Come on. Who's ready? Are you ready? No, come on, we can do better than that. Are you ready? That's better. Okay, so of course, none other than Nifty and Alex will be awarding our fantastic hackathon projects and prizes. Over to you guys.
Thank you, Walton. What do we got, Alex?
How's it going, Nifty?
It's going very well.
Yeah.
I feel like the air is electric. I already made that joke. Sorry.
We got some prizes to give out.
We have some great prizes.
Cool. Let's get started. First, a quick shout out to our phenomenal panel of judges. It's really impressive how, it's incredible how we get some of the best and brightest minds in our ecosystem to chip in at all of these hackathons. So thanks to Peter, Pedro, Evan, Eric, Madeline, Oleg, Michael, Kevin, Jean, and Felix for chipping in and helping adjudicate these projects. There were fierce debates in the judging room. Every single project was considered. Yeah, everybody got a good look. Now, Nifty, how do we judge our projects?
Yes, Bitcoin Plus uses the novel Women's Olympic Gymnastics grading rubric with
novel, yeah.
model. Yeah, we have 3 categories that each project is judged on. The first is what we call routine difficulty. So this is how hard is it, or what difficult of a challenge you set out to do? How hard is it to execute? Is it as simple as making a web request, or is it as hard as building a new protocol from scratch? We call that routine difficulty. The second category is routine execution. So how well did you actually execute the task that you set out to do? And the last is something we call general effect. This is how swag, how exciting, maybe you had a great presentation, maybe you stayed on theme, so it was more lightning focused than the others. And these are the 3 categories that each project is graded on.
All right, so let's give out some prizes. First, to talk about the BitVMX challenge, Pedro from Fairgate will give you the floor. Yeah, grab the mic from Walton.
Thanks, Walton. Okay, so for BitVMX prize, there's no winner yet. The prize will be open for a month, so you're still able to win those 2 million sats. We will be posting on Twitter, on Fairgate or BitVMX. Yeah, you can apply online on on the post. So that's it.
Oh.
Thank you.
Yeah, massive shout out to Fairgate for putting up this phenomenal prize. Yeah, building up BitVMX is a daunting task for the 24-hour hackathon, but you have another shot. So if you guys are interested, absolutely take a look at their hackathon that they will be throwing for this challenge and earn quite a lot of sats. So. Next, talking about Tollgate. So Tollgate is a free and open source sovereign Wi-Fi infrastructure platform powered by Bitcoin payments. This prize was for the best use of Tollgate, offering a super cool GL-MT 3000 travel router. In addition, this is another Uno reverse card. So yeah, building on Tollgate, yeah, the Wi-Fi router proved to be too much for the teams this time around, but the Tollgate team has generously offered to work with Murph from the Bitcoin++ team to set one of these up at the next Bitcoin++ conferences. So in Taipei, we're going to have Tollgate running for Wi-Fi infrastructure, and we're going to throw this challenge again. So in Taipei, if you want to go for the Tollgate challenge, start thinking about your ideas now, and you'll have another shot at this challenge. So thank you, Tollgate. Moving on, best beginner hack. So winning tickets to a future Bitcoin++ event. This prize is only eligible to teams where each and every member is a first-time contributor to Bitcoin open source. This prize goes to Satoshi Bot. Oh yeah.
Satoshi Bot in the house.
Yeah, so also, if you're comfortable being on camera, feel free to come up and grab your prize and take a picture with us on stage. If not, you
can come up over here, maybe.
Yeah, or not even. Just stay seated and grab your prize after. But if you're here, then absolutely.
Oh, this is for you.
Congratulations. Congrats.
Congratulations.
All right, it's nifty.
Next up is the best design, winning 50,000 Satoshis for the project with the most intuitive, polished, and visually appearing user experience.
Yeah, let's bring up Eric to talk about the projects and the design as well.
Thank you, thank you, thank you. So yeah, this is a design prize, and we awarded this prize to the project that we thought had a little bit of extra magic, a little bit of extra flair, a little bit of focus on the visuals, the UX, something that just kind of had that nice design touch. And yeah, we deliberated and we picked a winner. Oh, this project, this prize is sponsored by the Bitcoin Design Foundation as well. They are a nonprofit that is helping to boost the design of Bitcoin so you can support the mission. Go to bitcoin.design for the Bitcoin design community, and you'll find a link to the Bitcoin Design Foundation there as well.
All right, and the winner is?
The winner is a Rectbot 9000. Congratulations.
Gonna hand in this. Oh, congratulations, yeah.
Eric.
You want to take a picture?
Yeah, of course.
Go for it.
Join us, join us.
Congratulations, Rectbot. Moving on, can we have Felix up to talk about the best use of Electrum, or the best Electrum plugin?
All right, so yeah, the choice was easy. There was only one submission. The Glacier Wallet project. And yeah, thank you for taking the risk on building on this new platform. I guess you're the pioneer. So, yeah. You will get this nice prize.
Cool. Yeah, come up after and grab it. Moving on to the best use of LDK, a massive shout out to Spiral for throwing up this challenge, including a BitKey hardware wallet for the winning team. This project goes to the team with the best use of LDK, giving special recognition for projects with showcases for Bolt 12 or BIP 353 human readable addresses. So this prize goes to Mandal. Congratulations.
Congratulations.
Congratulations. Evan.
All right. For our prize, we were looking for someone that helped eCash mints gain reputation by crowdsourcing. And we didn't get that at all. However, we did get a fine project that caught our eyes, and we're giving our prize to Mint Anywhere. It's a CDK Cashu dev kit with NixOS. It's really going to help us make it easier to spin up a Cashu mint, and we think it's going to strengthen the ecosystem. So come up here, good sir.
All right, Peter.
Yes, so this was the most unnecessary use of open timestamps in an otherwise serious entry. And we really had sort of two competitors here. One, of course, is Rectbot 9000, and then the other one is SatoshiBot. Thing is, though, it's an unnecessary use, and Rectbot 9000 might enslave all of humanity. So having a historical record of the way it enslaved humanity through its Nostra post, I think is actually a very necessary use. Thus, it's SatoshiBot 9000 who gets it.
Congrats again, yes. Yeah.
Congratulations. Nifty, would you like to present the best Vibes prize?
Yeah, so a big thank you to Vibes Capital Management, the #1 Vibes Capital Management firm, and solely based on the internet. They are presenting the Vibes Medallion Clout for the project with the best vibes and most dazzle.
This prize is going to
Rectbot 9000. Do we have the medallions? Where are the medallions? Oh God. Okay. All right, we'll give you one of these, and then there's another prize that goes with this, and I don't know where it is, but we'll have to find it. So congratulations, guys. No, there's a you get like a thing. We'll have to like do it later. Yeah, thanks. Oh, hi. Cool. Congratulations for the vibes, guys. Yeah, really well done.
All right, moving on, we have our honorable mentions. These are overall phenomenal projects that deserve to be recognized, but didn't quite make it into the top 3. So these teams will be winning Bitcoin Plus tickets in addition to these sick trophies. So the first honorable mention goes to LN Split.
Congratulations.
Yeah. Also, there's a specific picture of a conference, but those tickets are fungible, so don't worry about it.
Cool. Thank you. Photo?
Yeah. Congrats. The next honorable mention goes to
Wally. No, not coming up.
The next honorable mention goes to Quiznuts.
Cool.
Congratulations.
Yeah, great job, guys. Okay. Kept everyone guessing on that one. Okay. Sorry.
Yeah.
Cool. Yeah.
Oh, Quiznuts, come back.
I'll get him.
We'll get you at the end. Okay. The next honorable mention goes to Floresta as a backend for NLightning. Congratulations, guys. Yeah, this was a super cool project. They put Floresta, the super futuristic Bitcoin Core library toolkit,
Gotta be
into
careful with
NLightning.
lightning in a forest. Something might catch on fire.
Yeah,
No,
that'd be dangerous.
Floresta means forest, right? In Portuguese. That's a fun fact. Okay. Cool. Cool. Thank
Congratulations. The next honorable mention goes to
Mandal. Cool. Congratulations.
Congratulations. Do we need to do another one? Oh, we have to.
We have to.
Congratulations.
Okay.
And our final honorable mention goes to
Rectbot 9000.
Oh, 2 more, yeah.
2 more members. All right, well, there you go. Congrats. Well, thanks, guys. No?
Yeah. Look at it. All right, moving on to best overall. This is what we've all been waiting for, 3rd, 2nd, and 1st place. So we have a massive prize pool. So first place was offered 2.5 million sats plus Bitcoin plus tickets. Second place, 1.5 million sats plus the tickets. And third place, 1 million sats plus the Bitcoin plus tickets. A massive prize pool. But shockingly, overnight, our prize pool was doubled to 5, 3, and 2 million sats respectively. Wow, 2x multiplier. And And who do we have to thank? Who do we have to thank for this gift? Well, none other than Jean. This angel has thrown his money in. So thank you so much, Jean. Cool. So moving on to third place, best overall, winning 2 million sats plus Bitcoin plus tickets. But first, we have some announcements.
Oh, wow. So I forgot about that. All right. Thank you, everyone, for coming to Lightning Plus Plus. This is the 12th edition of Bitcoin Plus Plus. Feels kind of crazy to say. Third one here in Berlin. Really excited to have everyone. Of course, have to give a shout out to our sponsors, our title sponsors of the whole year for making this entirely amazing experience with everyone possible. So a big thank you to NYDIG and the Human Rights Foundation for sponsoring. We really love our sponsors and we really love being able to throw these events. So if you're interested in sponsoring any future events, please get in touch. Yeah, so we've been doing events around the world. We just finished our scaling edition. Lightning Ambition is complete. We have one last mission for the year, which is going all the way out to East Asia for our first ever Asia conference in Taipei this December. Oh, no. So we'd really love to see some of you out that way if you happen to be going in December 15th and 17th. There's also one final surprise is that announcement for next year. We will be coming back to Berlin. The theme for next year is going to be payments. So we'll be taking our Lightning Edition and seeing what else is happening in the world of payments. Tickets are on sale now for pre-sale. I think there's like a super low price for the first maybe 21 tickets to go, and then they get more expensive from there. So no rush. Get good luck with that. Yeah, hopefully it works. I didn't test it before I shipped it, so hopefully that's all good. But yeah, this has been really wonderful, and we have such an amazing time here in the Berlin community, so very excited to see you guys here, as well as the rest of the world next year. Without further ado, I think we have a few more announcements or prizes to hand out.
Yeah, I think I lost my train of thought, but okay. But best overall, third place, winning 2 million sats, and Bitcoin plus tickets goes to Glacier Wallet.
Well, it might be chilly in Berlin. You can make it ice cold in your wallet using Glacier Wallet. No, okay, good job, guys.
Congrats. Sick project.
Cool, super cool.
Quick photo.
Cool, very well done,
Congrats.
guys. Yeah.
Moving on to second place overall, winning 3 million sats plus Bitcoin plus tickets goes to
Obfusats. Okay.
You will collect this prize after.
He's going to stay obfuscated, I think, for the moment.
Very cyberpunk.
All right, what have we got next?
First place,
Last but certainly not least.
winning 5 million Satoshis, Bitcoin plus tickets, and the title of overall winner of Bitcoin plus Payments Edition or Lightning plus Edition in Berlin goes to Nuts Are Pure Signal.
Wow. Okay. Let's go.
Yeah.
Congratulations, guys.
Yeah, these guys took the open source Signal app, noticed this shitcoin inside of it called MobileCoin, and ripped out the MobileCoin part and used the same UI to put Cashu payments in. So they have a working Signal with eCash payments inside of Signal that you can send to and from real Signal users. So congratulations, guys. Amazing project.
Yeah. I feel like they're keeping up the reputation of pure Signal at Bitcoin plus.
Pure Signal.
Pure
Yeah,
Signal.
yeah. Very on brand. Yeah.
So congratulations, guys. Cool. I think that's everything. Thanks again for a very wonderful last 3 days, guys. I don't know about you, but this is probably my favorite Bitcoin++. Hope to see you all in other locations and then maybe back here next year. So thanks to everyone. Anything about I should probably say a great big thank you to all of the staff, volunteers, all of our AV crew for an amazing job that you guys did. If you see a volunteer, please give them a huge thank you for all the work they put in. I feel like this is one of the smoothest run events we've ever had. So really feel like we had an amazing team, so thanks to everyone. And yeah, cool. Thanks, guys.
And massive round of applause to Nifty Nye herself for throwing another phenomenal event. So.
Thanks, guys. Cool.
Thanks to our sponsors. Of course, we couldn't do it without you.
Yeah, go. Yeah. Cool.
And finally, thanks to all of you in the Bitcoin Plus community. Thanks for being here, and we look forward to seeing you at the next one.
Yeah, cool. Thanks, guys.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin.